Okay, good morning, everyone. Welcome to week 7. These are the objectives for today. Today, we're going to look at the views and subqueries. And then tomorrow, I'm going to talk about variables and stored procedures. All right, but I want us to take a look at the lab questions for week 6 before we get into views and subqueries. So, just a moment, let me pull that lab 6. So, I understand lab 6 was a little bit tricky. So, we're going to review it. 6. So we're looking at case statement, this one right here. So I'm going to open that. Okay, so this is what we had for the lab session. We had this question right here, which is based on this query. So first we connect to AdventureWorks 2022. Then we had this case statement, this portion right here, that's a case statement. We're doing some aggregation right here. We're doing some joins as well. So if you execute this query, it's going to fail. Right? There's definitely a syntax error right here. So if I run this, it fails. The next thing we're going to do is check out the instruction. So below you see a script. The purpose of the script is to show a count of each person type. And there are 6 of them, 6 person type. However, the script has 3 errors. 2 of the errors will not allow the script to successfully run. I think we've seen that already. If we try to execute the script, it fails. So there are 2 errors blocking the script from running. Right. And then the next error, the other error is causing the script to show incorrect results. So they want us to fix the script so that it runs and shows the correct results. So 2 errors are preventing the script from running, and then 1 error is showing incorrect results. Okay, so this is it. And they even say you should try accomplishing without running the script. And so usually when you see a bug, stuff like this, of course, it's a lot. There's potential of an error. So we first of all going to evaluate this case statement and see if everything is fine and it follows the syntax. So this is a good start, the case keyword. This right here, it's the when carries a condition, the then carries the outcome. So that's really good. So the table in table person type is stored either in these are abbreviations, and there are 6 of them, just like what the question says, 6 person type. So we are using the case statement to make it descriptive. So when you see this in the data, this is the business meaning of that. You see? So we are using the case statement to make the person type more descriptive. Instead of having these abbreviations, we want to get it more descriptive. So you understand this portion right here. And it's nicely done. All the 6 codes have been fully described. See? Now the only problem with the case statement is that it needs an end keyword. So this is the first error. Right? For the case statement, once you've defined all the conditions, you need to put the end keyword. So this is the first error in this script. I'm going to put it right here. So the first error was missing end keyword. Right. So missing end keyword. So missing end keyword in the case statement. Right. This is very important. So you're missing an end keyword in the case statement. So that's the first error. Remember, the question says there are 2 errors which are preventing the script from executing. So we'll fix the first error by putting the end keyword right there. If we execute this again, it's going to fail. We need to fix the second one. See? Right. And the second one, now we have 2 columns. This will generate the column. There's this other one which is going through a count process. So aggregation has been used. when you see an aggregated column and a non-aggregated one, what do? You have to group by the non-aggregated one. See that? So I have to put group by right here. Group by person type. You see what we get? So 2 errors have been fixed. The 2 errors have been blocking the execution of the code. The 2 errors have been fixed. So the second error has to do with group by. So we're missing a group by, missing group by. So you see that we're missing this group by. You understand that this is a non-aggregated column. This is aggregation. So we have to group by that non-aggregated column. So this is what we get. So remember, there were 3 errors. So 2 were blocking the code from running. We'll fix the 2. The third error has to do with incorrect results. Let's address the third error. Has to do with incorrect result. And I'm going to highlight the incorrect part. So remember that we were told that the person type should return 6. And these are the 6 we defined in the case statement. But when we run the query, instead of getting 6, we get 4. So we are missing some outcomes in this query. If you go back to the question, it says that the other error is causing the script to show incorrect results. We are supposed to get 6 of these person types, just like what the question said. Each person type, there are 6 of them, but our query is giving us 4. Now, this is something you have to remember. If you do this in a company and you're getting incorrect results in terms of the number of rows returned, we are expecting to get 6 rows, but we are seeing 4 rows. Now, this is always the issue. One of the potential issue is the choice of the join that was used. You have to remember that inner join restricts data because it's only looking at the intersection, right? In fact, let me draw this out. There's a huge possibility that an inner join will return fewer rows than a left join. And of course, you have to understand this. Let me draw this out. For an inner join, we are dealing with just the intersection, just this portion, right? So there's a huge possibility that there will be few rows returned because of this restriction right here for an inner join. If you're dealing with a left join, this is the situation you are dealing with, the final result. You're dealing with the intersection plus everything outside the intersection on the left table. So these are the 2 zones you're dealing with for a left join. See? So there's possibility of more data being returned for your left join compared to your inner join. Compare this region and this region. Which one is going to give more data? Definitely this one. So if you're missing data in your analysis, instead of 6 rows, we got 4 rows. The problem is more likely the choice of this inner join right here. If we replace the inner join with a left join, see, so when we get to the second table, bringing the third table into the picture, we're going to the data. And most likely the 6 rows we're not seeing, we're going to be able to see them. So that's what I'm going to do next. I will just simply target my inner join, right, and replace it with a left join, and then run the query and see. So this is something very, very important. Usually when you're projecting less data compared to what the business needs for that requirement, you have to inspect the join type. So if I run this, now we're able to see all 6. And that's exactly what the question wanted. So we need to see all the 6 person types, all 6. Right? So you discover that the inner join was actually blocking that process. So now we've switched the inner join to a left join. We are now hitting our target. Right? So the third error was replacing inner join with left join, replacing inner join with the left join. Right. So this is something you just have to watch out whenever you're looking at questions that involve missing data, right? And you're joining tables, and one of the joins involve an inner join. Have this picture in mind. Inner joins are very strict. They're going to lead to fewer rows being returned. Unlike left joins, you're targeting two regions, two zones instead of one, right? So this is very important. And now this is the final solution, so that if I execute this, the two errors that were blocking the script from executing have been fixed. And then the one error that was reducing the number of rows returned has also been fixed. So in total, 3 errors. Any questions so far? I'm going to provide the script, so don't bother. Just focus on the concept. I'll provide this script and the explanation at the end of today's session. Okay, let's go to the second question. How many products are sold by AdventureWorks? Right. If you go to, I think to solve this question, you need that data dictionary, and also you need information about the schemas. Anyway, the different tables available. Anyway, you can still consult the database. AdventureWorks. You're talking about products. There is a product table. So for those who attempt to solve this question too, and were blocked on the table to use, right? If you're talking about products, it's going to be the products table, most likely. So this, then we go to tables. So the first table we're going to consult, it's just the products table, because the question is how many products are being sold by AdventureWorks, and we have a products table. So there is a product table. It should be, I think, product right here. So this could be your first guess. You can just stop right there and do a select star from that table. Select star from, this is going to be product. Okay, so let me execute this. Right, and if you also go to the data dictionary, now I want to count the number of products. What table, what column can I use to do the count? Right, so this is a product table. It begins right here in the production schema. This is the beginning of the product table. So the first column right there is product ID. It tells you that this is a primary key for product records. So no two products will have the same. All right, this is a unique key on this, is a unique identifier. All products should have a product ID, and no two products should have the same product ID. So the best way to count the number of products is to count based on the product ID, right? So that's the first column you see right here, product ID, and the description is available in the data dictionary. Some other people can decide to use the product number, which is, it says unique product identification number. Yes, you can also count products by counting on their product identification number. So you either use a product ID or you use a product number. These are the key thing is unique. See, the primary key is unique. The product number is also a unique column. So you might choose to do the counting. Let me show the two options and we can compare them. Choose to do the counting by targeting the product ID, which is a primary key. We know that every product has a product ID. So we can explore that business information. I'm just going to target this and put count, and we are counting the product ID. And this is going to give us a number of products. So if I execute this, this is what we get, number of products, 504. Some other persons will solve this by putting an asterisk. I'm not a fan of this. It's still going to give you the same 504 right there. Right, I rather prefer to target a column and do the count on it. Second option, you can do the count using the product number. We just saw the definition on product number. It is a unique identification number. So you're sure that no products will be counted more than one. And this count will also give that same information. See, so all of this is backed by what the business is saying about those columns. This is very important. Any question on this? All right, so first thing, I just wanted to make sure I give you some questions where no table is provided, but reading the business context of the question, you can understand what table to target. Now it even gets more interesting when we get to the second part. How many of these products are actively sold by AdventureWorks? And I did put this indicator right here. So if you go to the table, there is a finished goods flag. It's a column finished goods flag. What's the meaning of 0? 0 means that the product is not a sellable item. Why 1 means the product is a sellable item. So if you're looking at the products that are actively sold, you just basically need to introduce a condition which will highlight these ones right here. So of these 504 products, what we calculated right here, some of them are not sellable items, while others are sellable. So the follow-up to this question, the B part wants you to only count those that are actively sold. Again, if you go to the data dictionary, you're going to see that finished goods flag, 0 product is not sellable, 1 product is sellable. So we need to introduce a condition in that counting process. You can use any of the steps you use above, but then you need to now introduce a condition. So if I go with count with this approach, I will need to introduce a condition to only count those ones that are sellable. And in that case, the finished goods flag should be equal to 1. Those are the sellable products. And these are the products that are actively being sold. This is what you're going to put. See that? And if I execute this, the count is going to reduce, of course. We are down to 295. Right. So these are actively sold products. Number of actively sold products. So you have to understand that in A, we're just looking at the general number of products that are available. B is more focused on those that are actively being sold. And then what do we have for C? In C, how many of these active products are made in-house versus purchase? That classification of in-house versus purchase, again, you have to consult the data dictionary. You find that under the make flag. So this right here, make flag, it says that 0 means the product is a purchase product. 1 means the product is manufactured in-house. And that's how, so we have to take this number in B and show how many are manufactured in-house versus purchase. That's the question for C. How many of these active products are made in-house versus purchase? So you need to explore the definition contained in this column. This gives you the business process behind that. See, make flag is 0 if the product is purchased. Otherwise, it's going to be 1 if the product is manufactured in-house. So if you want to do the split between in-house versus purchased, you need to explore this information. All right, remember the goal is for C, the goal is to do this further classification, in-house versus purchase. All right, so it's a continuation. We're going to stay right here, take this, and then put it right here and do the manipulation. So we have to split things into two. This is very important. This is where things become interesting. We will need the case statement to do that. So case when the make flag is equal to 0, then we're just going to call this purchased. Right, make flag equal to 0, then this is a product that is purchased. Right, I'm just going to put this purchased right here, and then I will just end the process right here. Else, anyway, let me give an else null, and then I end the process. So see what I'm doing? I want to split the column into two parts. Right, we have all this information contained in the same column. In that make flag column, we have 0 and we have 1. So I want to go into this column and split into two, so that when we're going to use the count function, we'll count it on the two different splits. This is very, very important. All right. To solve this question, you must target that column and split it into two, and then count them separately. So the first split I'm doing right here is going to generate the purchased items. The product is purchased, and I can still use the same name right here to provide the column. End this process, and then this right here, the utilization right here is the column name, while this right here is the value, the meaning of 0. And I can do the same. I'm going to put a comma right here and do the same for the opposite scenario, which is an in-house product. So I can just copy this, all right, and I just replace, whenever I see 0, I replace 1. The meaning now changes. This is in-house. Just copy this, and for in-house, I will need a square bracket for that process. In-house, that's for the value, and then for the column name, I will need this. When I execute this, you're going to understand what we're doing. So if I run this, I've now split the make flag column into two. In fact, let me give you an original copy of the make flag column so that you understand what we're doing. We are taking this column, we are splitting into two parts, and these are the two parts, so that we can use the count function on this and count function on this. If you use a count function on this, what are you getting? You're getting the total number of purchase items. If you use a count function on this, what are you getting? The total number of in-house items. But originally, this is what we get. We cannot target this column and just put the count. That's what we did in B. The condition, see right here, with this condition, you're doing a count on that. It's general count, right? But you have to split the column into two parts. In-house versus purchase. You do the count separately. This is in-house. If I put a count on this logic, it will give me the in-house items, count of the in-house products. If I do a count right here, I get the count of the purchase, and that's what we're interested in C. Split the count you got in B into two parts. How many of these 295 items are in-house products and how many are purchased? So I want you to follow this logic carefully. These things show up a lot in businesses. You have one column, but you want to do two independent counts or three independent counts, or for whatever, you have to isolate them. See, I'm splitting them out into two different columns so that we can now use our function to target any of the aggregate function to target the columns independently. And the logic is correct. You see, when the make flag is 1, that's an in-house. So under in-house, some other persons will use a 1-0 notation, which is already right there. So there are many ways to actually solve this, right? But then you understand the idea of splitting this column into two parts. Now, the count function does not count null, so you just keep it will count only things that read purchase, and this will be the number of purchase items. If I go on the in-house side, I put a count. Nulls are not counted. Null is not a number. It will count this, skip this. So now you're counting the in-house item. You see, that's the idea. So this is just the first part. Now the follow-up to this is when we do the actual counting, which is now simple. Just target this logic, Control X, and then use the count function. What are we counting? We are counting that column we got earlier. This is counting this one. This is very important. I made a mistake and added the AS. You don't add the AS. This is the actual logic. Right. And then now this name. Now you understand this is a count. The column changes now to count. That's a counting process done right here. It is counting the purchase items 1, 2, 3, skips all the nulls and goes and continue the count 4, 5 all the way down. We're going to do the same thing on this one. So we take the logic. This is an alternative way to do this, where you just go through, apply the count function. I don't like doing this. And then you go all the way to the end. Sorry about that. This is where the logic ends. You enclose it. See, that's another way. Preferably, you can just cut this out, write the count function, put the parentheses, and then you paste the logic inside. What are you counting? You're counting this logic. Right. So this is us wrapping a count function on the purchase column and also a count function on the in-house. And this gives you that nice split. And I no longer need this. Right. These are the two things we needed. You see that? And if you add this plus this, we go back to that 295 we had in B. These are the number of actively sold products, 295. Of these 295 actively sold products, how many of them are purchased in-house versus manufactured? Sorry, how many are purchased versus manufactured in-house? And that is the split right here for the first phase. And then this is the actual count. And that's why when you sum up this plus this, you go back to the 295. This strategy is very, very important. Sometimes you are not just targeting a column and doing the count directly on the column, like what we did in this. Right, you will need to target the column, split into two parts, and then do a count on each part separately. This column has been spread into two, this and this, and we are now counting them. So this is very, very important. Right, you have to understand this process. You will need this in a good number of questions in the company. Sometimes things are not direct. They don't give you a direct column. Right, the column might be hosting so many information. You go there, split them out in the way you want to count, and then apply the count across the logic you've built. This is very important. Right. This is taking analytics to the next level. You see. Right. I really want you guys to go back home and practice this. Right. This process right here. So that's for C. Any question on this? So I just wanted to follow the understanding. You go back home, you practice. I'm going to provide you with this script. That's why this lab session was very, very important. I'm coming back to it because I know it has some very, very critical processes that you're going to cover. Yeah. So let's go to question 3. Use the human resources of employee and person tables. So for this question, you need to use these two tables. When you read something like that, you just have to stop right there and figure out a way to combine those two tables. Using two tables in a question, you definitely have to come to find out a strategy to combine both. Right. So the two will be used together in this question. So that's the first part. And then I'm going to remove this and take it to the next line. So these are the two tables separately. I'm going to combine them and execute. And the goal is now to find what the mutual column will look like. Let's see if I can take this up. We have business entity ID. We have business entity ID. That's already something great. That's our mutual column right there. We can go ahead and join the two. See? All right. So now we can proceed to join these two tables so that we get ourselves ready for the subsequent questions under this project. So I will use the aliases. This is E for employee. Let's go with an inner join. If we are having data reduction issues, we switch to some other join. But since let's just be with an inner join. And if need be, we're gonna do some adjustments on the join type. So this is it. And let's get this P for person. We just talked about the mutual column. So the on operator comes in right there. We need the business entity ID equal to business entity ID. See that? Now the two tables have been joined. We are now ready. What is A? The A part of this question says, return the following information about employees. It's just now to call those columns the way they're listed. Right. So this has been joined. Yeah, I'm going to preserve that so that when you're studying, you see the join first. Oops. And then second, we start looking at the question. So for A, we're simply taking this. The list of columns to be returned have been specified, beginning with what? ID, first name, last name, hire date. So ID, that's just an alias. There's no column called ID. It's going to be this alias ID. So we're going to call business entity ID alias it to ID. And this is a mutual column. So if I just type business entity ID, the system is confused. You can trace this column to this table. You can also find this column on this table. So which is which? Ambiguous error. We know how to fix that. In an inner join, it doesn't matter where you plug it. Since we are dealing with this condition, right? So you can get it from any of the tables. It's going to be the same since it's equality. Inner join is looking at the intersection. So that's the first column right there, and they want us to return it as ID. The next column was, I think, first name, last name. So right here, let's get the first name, and let's also get the last name. What's the next? The next is the hire date. Hire date. Right there. And the next is the years employed. This is going to be a calculation. And this is the full definition, the number of years in the company from hire date to current date of this. So we are assuming the current date is this. So what function can we use to calculate the years employed? Can somebody help with that? What function can we use? We want to look at the number of years. Yes, go ahead.
Can you use the date diff?
Yeah, excellent. We're going to use the date diff. So this is what we have so far. We're just pulling those columns directly. But then the last one is an analytical concept. It's a derived column. We need to compute this. So that's the number of years from the date the employee was hired to, let's say the current date is this. So we need to, so that's a date diff, right? Duration, we know that in SQL, durations, difference between two dates are done through the diff function. Last time I want to talk about this, but I just completely forgot. In other SQL versions, you can just take this minus this. That's Postgres. You can do this in Postgres. And this date has to be transformed because if you look at higher dates, let me just go one step backwards so that you can see the higher date, the way the values are presented. You see, year, month, day. So that same layout, we have to respect it. So you cannot do this. Let me first of all demonstrate this aspect. Right, it's possible in other SQL versions, but not in T-SQL. Right. First, we cannot do this. Right. This has to be transformed so that it looks like this. So we have to present the year, the month, that was December, and that was December 31st. So this is the correct way to do it, so that it's in the format aligns with what we have on the hire date. So this is the point I want to make. In other versions, you can do this. See that difference between two, they just take this minus that. See, but then you see, I get an error. Right. So this process can be done through a date diff function, right? Where you just simply now have to use these two as parameters or arguments to that function. Now, this is where the function comes in. Date diff. We are calculating the date diff. The date diff function requires 3 parameters. I've provided just 2. I'm missing 1. And if you put your cursor right there, it tells you the date diff function requires 3 arguments. We've provided 2, the start date and the end date. This has to be calculated in years. What's that? Oops. Right here. Years employed, number of years in the company. So we have to tell the system that that outcome will be quantified in years. That's the parameter we are missing, or the argument we are missing. Now our date diff function is accurate. It has 3 parameters. We are calculating the number of years from this start date to this end date. And if I execute this, this is what you get. So this is years. And the question actually gave you the name to that column. See? And if I go ahead and execute this, I think that's the end of part A. So A was simple. Let's go back to A. Return the following information about employees: the ID, first name, last name, hire date, years employed. I really want you to see this process so that you understand the steps to problem solving. Don't just go all over the place and confuse yourself. Do it step by step. See, so that's the end of A. This is
Mr.
really
Bliss,
important. Yes, question.
I got a question. Right, let's see on the date format of the current year, which is December 31st, 2013.
Right.
Did you still have to convert like to match
Yes,
with the higher
yes,
date?
yes, that's very
Oh,
important. Yeah.
because
If
in that
not,
case, I did mine with the format month, day, and year, but I still got the same outcome. So
okay, that's a good discovery. Yeah, so let me address that. So you did, so in your case, you switched it to, yeah, I think the system is
31st.
intelligent enough to understand that. So let me switch this. So you started off with the month. No, you started
Yeah,
off with what month? Okay,
I started with
so
the month, then the day,
okay,
then year.
so month, day, yeah, so month. This one has to go to the back. So the month, the day, and the year.
Yeah.
Yes, it still gives the same. Yeah. So the system was intelligent enough to spot that and fixed it. Right. But you have to understand that the traditional way of presenting dates in SQL, we can just get that from what SQL itself says just by pulling the get date function. Run this. Year, month, day. So I'll always encourage everyone to use this. Yeah, this one also works. This is a good discovery. It's also good to highlight that so you're aware that. Right. But one thing we can all agree is if you just take this right here and just plug it into that, yeah, the system will have some issues. You have to understand that this is a string. Data type clash. This is a string. This is a date. The data types are not the same. And since the date function works on date, it's a function we saw under the date and time. See? So by exposing the date function, it is already expecting to act on date. This is a data type date. This is a string. This cannot be classified as a date. This is a string. See that? So you see, it gives you a conversion field. Whenever you run a SQL code and you have conversion field, that's a data type issue. So one of the data types are not compatible. And it even tells you conversion field when converting date and or time from the character string. So it has identified that this is a character string. And so it's attempting to convert this into a date. Why? Because the date function is a date function, which means it works only on dates. Right. So that's a very good discovery, Alex. Yes, this arrangement is defined. This is a date. See, and one of the things you can do, does SQL recognize that as a date? I want to do a test. Remember, we have the isDate function. You can just use that function and pass anything you're trying to test. If it's a date to it, and then run it and see. It's an investigative function. When you get 1 means yes. When you get 0 means no. For example, let me just distort this a little bit. We know that there's no 32 days in the month of December of the year 2013. So if I run this one, the investigation will be 0. This is not a date. All right, so that's already a good indication that if you put it like this, system recognize that it's a date, and so you're good to go. All right, let me do the same just to make this concept complete. Let's do the same. Let's see what the system will report on this. If we expose this right here to the system, let's see the verdict we get. 0. It's not a date. Right, so the system does not recognize this as a date. So these last two are not dates. Right. Meanwhile, this is a valid date, so we get the investigation result. 1 means yes. These are investigative functions. Yes or no, 1 or 0. You see. Yes, that's a very good call. I like that. So that's very much approved. Okay, so if we go through this, this is the A part. Now in the B part, add a new column called years employed grouping. This is where the case statement comes in. Right, using the following logic. So employed less than 1 year. So you're using the last column you built in A, which is this one right here. And then you want to group employees based on this logic. Employees that have been in the company for less than 1 year. So the years employed, if it's less than 1, we're going to put them in this group. If they've been in the company between 1 and 3 years, we put them in this group. So this grouping structure is also indicating the condition and the label as well. We have to discover that. So this was a scenario where I was just wanting you guys to make use of the case statement to place a calculated column into different buckets. Right, this is very important. So in B, I'm going to put B right here. It's a continuation of A. We are simply going to target the last column in A, and we're going to use the case statement to do a nice grouping on that. Just permit me go back to the standard way of doing this. Right, so we are targeting this, right? So you just have to understand that's a scenario you're going to solve using the case statement. So it's going to be a new column. I'm just going to introduce the case, right? And what are we using? This right here. You cannot use the column itself to build this, right? When you're executing the select clause, everything on the select clause is executed together. So you cannot build something and then you use the name in the next line on that same segment. The system runs this code segment by segment. When we get to the select clause, everything on the select clause is executed. So if you build a logic, don't use the alias on that same concept. use the original logic. This is the original logic, which is calculating what the duration. So we're going to be saying case when this duration was the first condition. When this duration is less than 1 year, this is the return. Right. So this is what you're going to do when that duration, where is it? When that duration is less than 1 year, then what are we getting? We are getting this bucket. This is going to be the label on the employee, employed less than 1 year. So all employees whose duration in the company is less than 1 year, this is the value they will get for the new column we are trying to build. This is very, very important. See that? And you have to just keep doing this until you exhaust the list. The next segment is this one right here, employed 1 to 3 years. This is what is a range. So nicely, we can use a between operator for that. See? So I'm just going to go to the next line, bring in the when, state the condition. This is the duration. This is the key part of this question, the duration. When this duration is between, since that was a range, between, I'm just going to use between, and it's an inclusive range as well, between 1 and 3. Then what are we getting? This employee should have this value for the new column we are building. I want to do this gradually so you see this. This was a very important lab session, right? Having very strategic business questions, right? So there's a lot of tricky things involved in this, but it's easy. You can understand what is going on. See, this is very important. This is that range 1 to 3, 1 and 3, and this is what they get. So this is the condition we are testing. If this holds, then every employee will have this as a value in the new column we are building, right? This is very important. And I think by now you understand the flow. I will just go to the next line, find the next condition. All of this is built on the duration which we calculated. So on this duration right here. So I'm going to copy this and put right here and then go investigate the next classification is this one. Employed 4 to 6. That 4 to 6 again is a range. All right. So I'll still use the between operator right here. That's still a range. We can all recognize that between 4 and 6. Then what do we get? I just copy that value. We have to return this. See, employed 4 to 6 years. You have to continue this process right here. I can just end right here and just do else. I return this one. All right, you see, if we have 1, 2, 3, 4 conditions, you can define 3 and you push the last one onto the else block. The only issue with this is if an employee's hire date was not presented, then of course you understand that this logic, this calculation of duration is heavily dependent on the hire date. If this is missing, then this entire function will return null. And if it is null, then your else block will be pushed to this over 6 years, which is not true. See, so that's why a lot of persons that prefer to, when as a data analyst, you're building codes, you're solving problems, not just for it to work for the current situation, but also in the distant future. So what will happen if an employee is hired and their hire date is not documented? Then if I end the process right here, I do end right here, and I push everyone to this category, employed over 60 years, then you start having issues because anybody that has a missing hire date, this logic automatically sorry, not n does not come right here. N comes at the end, just like what it says n. So else I push it to this. So if an employee is hired and there is a missing hire date, such an employee will be considered in this. This is what they will get for that new column, which is not correct, right? So I'll always advise you when you're working with these kind of questions in businesses, go ahead and define all the possible solutions, all the possible groups, the way they are stated, and then generate an else and push it to null. So when you start having those nulls in the report, you know exactly what went wrong. You see, but don't use the else and just push it to the last category, because if there are issues in the data, you will not be able to spot them. For example, an employee is hired and there's no hire date. This calculation goes to null. And we are saying that if you are not in this, you're not in this, else you're in this. So such an employee who has a missing hire date will then be pushed to this category, which is not true. And again, you will not be able to spot it. But if you use, so this is the route I want you to do. Go ahead and fully define this. Right, when the business gives you their definitions, go ahead, fully implement everything. So in this one, it's going to be when this is greater than, see, over means greater than, over 6 years. 6 is already in this, so we have to put strictly greater than 6. So when this happens, greater than 6, then we are getting this. This is now correctly defined. So you only get employed over 6 years when truly your duration in the company is greater than 6. See? Now, before ending this process, I can now create an else category to take care of any scenario I have not defined in these 4 definitions. See, that's the power now of the else. You can now push a null, else null, and then you end the process. You see, this is the best way to do this. I've been a victim in this in projects when I started working as a data analyst. You see, I'm very, very slow in typing, so I like to use shortcuts. 4 conditions, I type in 3, push the last one to the else block. See? Very dangerous. Right. Define all 4 and create an else scenario with a null. So that if anyone shows up with a null, yeah, you take care of that. It will show up. In fact, let me demonstrate this. Let me run this, execute. See, I will then go back to the data. I want to mess up this data. Let's target Sydney Higa. I will go to Sydney Higa's data and mess it up. All right, I will put a null on the date. Let me show you how to do that. This part of the question, I will come back to it. I haven't showed you how to define databases. Yes, let me go ahead and mess up this Sydney Higa's data. Let me first of all preserve this because I need to, this is the value I'm going to mess up. I'll change this into null so that you see how our function, our logic will react. So I'm going to target this and change it to null. So you have to know the table you're targeting. What table are we dealing with? Higher data coming from the employee. So go to employee, human resources. Please don't do this. Let me just do this for demonstration. You don't need to do this. I just have to go to the edit on the table. Editing on a table gives you now the power to edit the records in any given table. Yeah, the data shows up in a different way. The individual I was targeting is this entity ID 50. 50 right here. This is a row I want to target and do an update on it. So the technical term for what I'm doing right here is called an update. Right. I want to go into this table and change the value of the higher date. You see this date right here. I want to change it into a null. hidden. Immediately it is implemented because there's no asterisk, and then I can shut this down. Invalid value for cell that. Okay, I didn't I didn't preview this. When it tells you invalid data for this, you have to read further. It means that higher date is mandatory. And so a column that is defined as mandatory, that column cannot take a null. Let's read further. I just spotted that, but let's read further to see what it says. Invalid value for cell this. That's the value I'm trying to change on that row 50 is invalid. Column 10. So 50, column 10, it meets right here. The rows and column interaction is 50, and the rows column 10 meets right here. So the change value in this cell was not recognized as valid. Right. Date time error message cell does not allow null. That's exactly what I was explaining. So if you check the constraint on that column, let's go back to that column. You go to the column section and you check the constraint on higher date. It is going to be not null. All right. In the last part of this training, we're going to talk about designing databases, creating tables, inserting records. You're going to understand this much more better. Right. This is taking forever to expand. So I just want to take you to the column section, and then I take you to higher date, and so you can see the constraint. So when you're defining a column, you must state the name of the column, the data type, and then any constraints. For example, not null, null, unique. Those are constraints you can impose on the column. This is taking forever to load. Let me see if I can. Another way is to go to the column, just put your cursor, and you're going to see that information. The column, it identifies this as a column. The name of the column is higher date, and the data type is date, and the constraint is what? Not null. Not null simply means you're dealing with a mandatory column. So that column must have a value. That's the meaning of mandatory. It's a compulsory column. So any record you put in the table must have a value for higher date. So any employee you hire into the company, if you're entering their information, that column must have a value. You cannot skip it. You cannot leave it blank. Null. See, that's the meaning of not null. And that's the issue I'm trying to do right here. I'm targeting that column. I'm trying to insert a null on it. The system has built a constraint on that column, and you cannot violate this constraint. This is very important. This segment is very interesting. I will come back to it. That's going to be an interesting session because we've done all the SQL stuff, and then we just relax and go over how to build databases, how to create relationships, how to insert data into columns. We're going to see how to update. You can call your bank and you want to update your address. They have your record existing. That's what we call an update statement. To delete data is a delete statement. We're going to talk about that. So, right. So this has been rejected. There's nothing I can do. I can only go back and change the constraint from not null to null before this value can get in. You cannot insert a null on a column that is built to be not null. All right, this is very important. So this, no matter what I do, this value will not go in. That's the power of SQL. And that's the power of constraints, the conditions you've set on the column. Right. So I cannot violate that. I just have to abort this process. Right. And sometimes try a value. I'm just going to go back to the original value. Well, that's why I had to store that original value. So if I have a roadblock, so I just have to take this value and put it back. If not, the system will not allow me to leave this environment. Right. Now we're good. So that column must have a value. So what I was trying to explain to demonstrate, unfortunately, I cannot proceed on that because of that. Yeah, but this, I just want you to take note of this. When a business gives you their definitions, apply all of them and then create a scenario for any unforeseen circumstances. Right. So else null. This is you being aware that, hey, things might go wrong in the near future. Right. It will take care of that for you. Okay, so if I go ahead and run this, Now this is a new column we've built, and did we have a name for that column? Go back to the question. Definitely there was a name provided by the business, and this is it. Years employed. That's the grouping version of that column. So we just have to copy that and put it in the case statement at the end of the case statement. The AS keyword is optional. You can put it or you don't want to put it, that's fine. So this is it with the AS keyword. Some other person might choose not to use the AS keyword. Remove this, it will still execute. But you will be doing a fatal error if you fail to end the process, right? And that's what we saw in the first example. A case statement cannot work without the end. See, you have to tell the system, this is where my logic ends, right? So the end keyword is very, very important. That was one of the errors we saw in that first question, right? You have to watch out for this. And this is it. So you see, this is built on this, right? This lab session was very interesting, and there's a lot to learn. I would encourage everyone to create time and go back and visit all the questions in this. Make sure you're able to solve them, right? Okay, so any question on this? This is what I'll give you the script. I just want to save time so that we can exhaust all of this, and so that you have this documented. You can now create time and go over it. If you have any other issues, you can just reach out to me. Now, in this question 4, in this question, you are required to use the query below as your base. This is the query right here. So they've already done the heavy work of joining all those multiple tables, and you're presented with this. This is a huge, this is taking forever to load. Okay, anyway, let's just wait and see if it's going to return anything. So while that is working, let me dismiss the output. It's still running behind the scenes. See? All right, so this query is going to be used as a base. The result in this question needs to include one row per sales order ID. See, this is the number of rows that will be returned. That query is still running. It's still fetching this 31,465. So whatever you're doing moving forward, your result should always keep showing this 31,465. Anybody looking at this will know, okay, we are heading towards a window function. For you to preserve all of this, yes, there will be no aggregation in a summarized way. Any aggregation we need to do it over a window, because only a window scenario will preserve this. They give you that clue upfront. The results in this question needs to include one row per sales order ID, and so your final result should always project this 31,465 rows. Now, why doing this? Include the following columns. This is just no logic. Sales order ID, you just fetch it and put it right there. Customer name, you just have to concat the first and the last name combined. That's a concat function. For the person type, we don't want to see the abbreviations. Remember this person type abbreviations with it. So you can just copy that same case statement above. You're going to use a case statement to spell out this. So it's the same case statement we saw in the first question. That's the same case statement we're going to use. This right here. This is it. See, that's what we need for that part. That thing is still running. See, it's 31,000 something rows. I think my system is slow. I think maybe in your case that query should execute. Can you guys try running this and inspect and make sure you get 31,600 something rows? Mine is still running. My system should be slow. Please, can you just run that query? Anyone, just run that query and check to make sure you have 31,465 rows returned. Can anyone confirm that?
Mine is still executing as well.
Okay, now yeah, that's a huge stuff. And while we are on that concept, let me just remind you of this. When I joined the company, I used to run queries select star from a very large table. right? And I will sit there and wait. You're slowing the process, you're slowing the server as well. And then you're slowing every other data analyst that is connected to that server and working on that particular table or set of table you're using. So as you see this running, I'm actually crowding that table. All the tables involved in this join, I'm actually crowding them. So other data analysts will start having issues, slow queries, because the system is using all the server resources to output this result. Right? And when I join the company, they will always complain that, hey, somebody's query is blocking traffic on a particular table and stuff like that. And they can easily know where that is coming from, because of course you log on to the server with your username and password provided by the company. So this is very important. If you are running a query, if you're seeing a table that has too many records, right, and you just want to run an investigation on the table, right, please always make use of this restriction. For exploration purposes, just do this, maybe top 100 or top 10. In other SQL languages, they use a limit. In T-SQL, limit is not supported, right? So this is very important. This is a very important advice for any data analyst just joining the company, right? In other SQL languages, they use this. You're gonna see the limit in PostgreSQL, Oracle, and others. They use this. So you see, that's why you see data analysts always write a select star from a table that is too large, and the limit it just give me 10 rows. This is what other systems will support, but T-SQL does not recognize the limit. They recognize this, so this is the same. Instead of giving me all the rows in that table, just give me the top 10. I don't want to see everything. I just want to see the structure of the table. That's the basic concept of select star from a table. You see how this is slowing down because on the server, there's a funny query running and taking resources. And that's how you slow every other person down. You have to understand that in the company, we are all connected to the server. This is your private laptop, you see, it's different. Even the company give you a private laptop, but the SQL server is on the cloud. It's on a server, a company server. This is very important, right? So when you log on to it and you run a select star from a very large table, the larger the table, the more resources SQL Server will need to show you the result you're requesting. So you've just now crowded the whole place. This is slowing down. See, this is also slowing down. Right? Any other person connected to that same table on the server, you're slowing down that table. There's a lot of traffic on that table. See that? And others will start complaining, right? And usually the database administrator then does a check and says, hey, sometimes they can kill your query if it's taking too long. So, or some administrators are smart enough to say, hey, they create a condition. If any query runs for more than this number of seconds or minutes, kill it. See that? So there's a lot you have to understand that in a company you're just running on your private server. It's a company server. See what is going on right here. Nothing is working because I'm trying to query this table, which is also involved in this busy join process going on right here. So it is slowing it on this side, slowing on this side, and if we're all working for the same company, Tunde is going to be complaining, something's going on in Dries, Lena, or everybody is just going to be complaining. See? So a nice way to solve this as a data analyst, if you're exploring a table, always limit the number of rows to be returned so that you don't send too much traffic on that table on the server. See that? This is very important. Right. Now I cannot proceed. Nothing is working. This is still running. See that? And the time, you see, this has been running for 7 minutes, 32 seconds. See, this is the runtime right here. This is a huge problem. Right. And it doesn't only end in SQL, it's going to continue to Power BI. If I use this query that takes 7 minutes to load, it's still loading, or 10 minutes to load to build a report. It means that if you open that report, it will waste that same number of time to load. It's something very important. It's like, let me just go to a BBC website, for example. I click on a certain news article, this one, I click on this. You see, the page loads and displays the content. See, that's how reports also work. You open a report that you've built in Power BI, it has been placed on the server. If you use this kind of query that is taking, this is now 8 minutes already. It means that whoever is using that report will have to sit there and wait for 8 minutes before that report can load and display. See that? And this has to do with the performance of your query. So as we study SQL, we go into higher levels. Your goal is no longer to write queries that will run. Your goal will now change toward writing performing queries, queries that have good performance. And that becomes an important part. Right? So in your SQL journey, after you've understood the SQL language, you can write codes. That's no longer an issue. Now you go a step higher. I want to start writing codes that have good performance. And what's the performance of a code? When I execute my code, it should take a few minutes to load and render the result. Seconds, we're talking about seconds. The CEO of a company should not click on a link and sit there in the report and waste 2-3 minutes of their time just to wait for the report to load. That's a huge red flag. A manager will not be happy. See that? So as you go to Power BI, right, report optimization, also in SQL query optimization, that's very, very important. Right. For now, we just want you to get that stronghold on the SQL language. The next level will now be to start, asking yourself, is this query performant enough? The load time, see, I'm still right there, 10 minutes, that stuff is still loading. Right.
Mine finished running actually. So
Okay, yours is, I think, yeah, mine just ran. Can you check the number of minutes yours took? Just go to the bottom right hand side.
it took 1 minute and 17 seconds.
Okay, mine went all the way to 10 minutes and something. So you see, it's also has to do with the server, maybe connections as well. Stuff, yeah. So this query executed successfully, but then mine is not giving me the requested. I think they should be, because I'm using. This question was gotten from the thing should be the database. How many records did you get? How many rows did you get? Can you check the number of rows?
I have the same as you.
Same. Okay, so it's not just. It should be an issue on the database. This is 2022. This question was gotten from the 2019 one. So when it got to 2022, it's a reduction, but that's the fine. So I'm just going to change this to 121 317. Okay, so this is the output. We want the first column sales order ID. So now I'm getting to solving the part A of the equation. This not. It's just a continue. Yeah. So A, bring in the sales order ID. This one right here. And we can just keep going now to that output and just modify it. So this is the output. In an attempt to solve this, I will just be doing, since this query is taking for long to load, I will just modify it. Maybe at the end we can run it. So this is the sales order ID. That's the first column we want. So we have the base query, just plug in the sales order ID is the first column. Go back. So we've added this, the customer name. So they want you to combine first and last name. You can do that through the concat function. So I think you're familiar with this. So concat, just a moment. If I see this right here, it's ambiguous. So you have to identify one of the tables. You see, for example, sales order header dot that. So sales order ID is an ambiguous column. So I need to fix that by pointing into that table. And let's concat first and last name. This is a concat function. This is a revision. Right. The first name, put a comma. We know we're going to need a space, right? And that's just make provision for the space. Then bring in the last name, right? And then this should be what? This is the requirement. This is going to be the customer name. So first we have the sales order ID. This second we have the customer name. And we just keep building. Of course, we now see this is having an issue. So we need to make sure that we are going to so customer names, they normally come from the person table, sales order. So we started with this header, we went to the detail on this and this, put in the customer, then the person. So this is CP, this right here. So first and last name are coming from the CP one. And last name are coming from this. Then there's, you see this version of person table is called CP. There's another version of person table, which is from the sales. The sales persons are different from the customer person. So this one is a customer information. So we're getting from the CP reference. The person table stores different types of persons, customers, salespersons. So you have to watch out with the alias you use. So this alias is when we join with the customer. So in this one, we're tracking the customer information. That's why the person table is of this version is tied to the customers. Right? There's another version we're gonna do for the sales. Now the person type, using this layout, the case statement, we have it above. I think you're familiar with this. You use the case statement. This is what you get initially. But we don't want this abbreviation. So this is what you do. Use the case statement to build that. I just want to save time on that. I'm just going to copy it since we have it already. So where is that next part? So yeah, almost right here. So we have this, and the next one is the case statement coming in with the person type. All right, and this person type, each person type, use the description below for person type. Now this person type, based on this column, it's coming from this one. It's from that same CP, the person. All of these investigations, you can actually do them. If you want to know where this person types are coming from, we can check customers or we can check person. I am suspecting the person table, and you can just do that investigation. Select star from. You have to understand that all these joins, the column, the tables have been alias, right? And person type has been used twice in this join with different aliases. So this is the first alias of person type as CP. This is the investigation right here. Right, run this, and this is the person type we are using, you see. Now there is a second reference of person type. Let me show you that. The second reference of person type is this one. You see, person, which is coming from this SP. That's why when we put person type, the system does not recognize it immediately. It gives ambiguous. Why? Because the person table has been used twice in this join. First instance, it was reference CP, this one. You have to understand that the column in the case statement is person type. Person type can be traced to this one. This one, it is cp.person type, this version. Another version of the person type is the one in the SP, this one. Person type, this is going to be referenced as sp.person type, this one. So which is which? That's why this error is ambiguous error. Right, this is very important. So the person type you are referencing in this, let's get the SP one. So in all of this reference, we have to put SP. All right, I have to visit each of this line and put SP. This is really slow, right? So let me show you an alternative. If you want to type the same thing across multiple lines, hold down the Shift button, hold down the Alt button, and then you press the down arrow. So Shift, let me put the combinations right here. Always remember this. If you want to type multiple, this is just short form. Hold down the Shift key together with the Alt key, and then press the down arrow plus the down arrow button if you want to go vertical. Right, the arrow buttons left, right, up, down, use them as per the direction you want to go. Right, arrow buttons, I'm just going to put arrow buttons. Right, you can test this on a new page. Copy that, put it on a new query window. I want to write a select statement that will explore 3 different tables. So I want to write select star from 3 times. I just highlight 3. Make sure your line goes all the way down. Then you go back up a little bit. Shift out, down arrow. I'm going down. See, I cannot go any further because my yellow stops right there. So if you want to go any further, you have to increase the yellow and then go back up. Shift out, down arrow. See, and I can stop now, release, and type select across. This is how you type across multiple lines. See, this is very important. It helps, not important, of course, it just makes your life easy. I want to type SP on each of these lines and they are properly aligned. You can only do it if they are aligned. So if I go to this shift out down right here and I just type SP dot one move and done. You see, this is just for lazy people. If you want to type this fast, of course, most programmers are lazy. You want to do things short way and get it done and move to other things. You see, right here, that's it. So I will put these key combinations right here. You can use that. So, and I also put this so that you understand that the person table was used twice in this join with 2 different reference. So person type we're getting from person table, we needed to be specific. Without this reference, we get an error. So that's C. We've done this. Right. What is D? The salesperson name. Remember, we've talked about the customer name. Now we're looking at the salesperson name. The salesperson name is the one that is coming from the SP1. The SP1. So you can still copy the first and last name from the customers, but then you change it. I'll just be lazy right here. Copy this and then change it. This right here should be from the SP. That's the salesperson first name. This right here should be from the SP. That is a salesperson last name. And of course, this is what the salesperson. That's the column we're building. Salesperson name. This, where is that? This one right here is a salesperson name. There are spaces in it, so I'm going to use that. So we're making progress. That was this information. Salesperson name, and there's something interesting is if a sales order ID doesn't have a salesperson, then specify no salesperson. I have to run this code. Anyway, let me just throw in the order amount. I'll come back. There's something we need to do on this. Let me throw in the order date and then throw in the amount of product quantity purchased. Amount of. So what was the next one? Put the comma right here. This is the order date. Yes. And then this right here is the amount of product quantity purchase. Amount of product quantity purchase, I will need to run this query to check what amount of product quantity. I think it's a summation on the quantity. Yes, we have to do some summation right here. And this is where that concept of a window function comes in. Remember, we're told to show all these rows. If I come right here and I use sum, what am I summing? If I'm summing the quantity sold, let me see if we have. It's going to be an abbreviation right here. I don't want to run this. Anyway, let's go back to the query. This is a query. No, not this one. Yeah, I didn't want to run that query again. Okay, other
So this,
quantity sold.
I'll send the column name in the group chat.
Awesome, thanks for that. That saves me a lot of time. This is the other quantity sold. Yes, other quantity, this one. Yes, and this is what we call the names provided. This is the amount of, just call it quantity purchased. I don't want to get a very long name. So this is it. Now you have to understand why this is not valid, because this is aggregation at this is summary level, right? If I run this query, it's going to fail because of all the columns I've listed, this, 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 and this, non-aggregated. This one is the only aggregated one. What does it mean? It means I have to take each of these non-aggregated columns and put them in the group by. But then guess what? We will not be able to see this number of rows anymore, because aggregation in a non-window environment will do the calculation for each group. Remember, the question says we should do this one row per this. So what calculation, so to transform this calculation so that we do it for each row in the tables, we need to use a window function. If you proceed to do this aggregate function without a window function, then without a window environment, then this will be the normal aggregation, which will require us to put this in the group by, put this in the group by, put this column in the group by, put this column in the group by, and also put this in the group by. And again, we will not be able to project. If you do that, you're now showing that summation for each group. That is a per group analysis. What you're asked in this question is to do a per row analysis in which all of these rows will show up. So how do you calculate an aggregation for each row? That is a window function. How do you calculate an aggregation for each group? That is a regular aggregate function. So this right here is aggregation for each group. That's not what we want. We want to do this aggregation for each row. Last lab, I did come up with an image, but I forgot to, yeah, window function diagram. I did come up with this. I saw this online. I just forgot to highlight this. See, this is regular aggregation. In a regular aggregation, you have this row, this row, this row. This green means that it's the same group. So this is what you get. You get one row per group. Since it's one group, you get one row. This is what you get in an aggregate function in a regular environment. So the goal here is what? Aggregate functions versus window function. If you use an aggregate function in a non-window environment, this is what you're getting. So it goes and groups all of these. This is one group. They have the same green stuff. This is this, and this is one group. So in an aggregate function, you look at the result per group. So all of these constitute one group. This is the result, one row, one group. And then the summation is done. You see? But then if you apply this in a window function, what's the power of a window function? It preserves each row. You see that the rows are kept. It is kept, it is kept, it is kept. And then the aggregation is added to each row. So a window function does aggregation for each row in. This is the 3 rows that went into the window, and you have 3 different outcomes. These are the 3 rows we have. We perform an aggregation with a group by. They are all collapsed into one. This is very important, right? Of course, if you look at this is partitioning now in the window framework. We want to do this analysis where we are summing up the amount sold by city. Let's see, yes, partition by city. See what it does. The partitioning, it takes all the Paris rows and put them in one window. See, a window shows you all the rows inside the window. It doesn't do any aggregation. No grouping is done. That's why partition by and group by is different. You can clearly see the 2 transactions from Paris since we are partitioning by Paris. See, this and this. And then it shows you the individual row sold amount. And then now this is where the sum function comes in. It sums up this and this and reports that value. You see right here, that value is reported for each row in the window. I saw this on LinkedIn. This is an excellent explanation to understand the difference between when to use a normal aggregate function without a window environment and when to use an aggregate function in a window environment. The window environment right here is city. So all the Paris rows are put together. You see it, this is a window. You zoom into this window and you see everything in that window. Nothing is hidden. All the rows are seen. And the aggregation is performed on each row. The summation of what? Summation of sold amount by city. This plus this is 800, and 800 is reported for each that window. So a window function performs an aggregation, and that aggregation is reported for each row in the window. See, we did not report this amount for each row. That's not what an aggregate function does. If you transform it in a window environment, that aggregation you see right here will be returned for each row. A window function preserves the identity of each row. See, this is very important, right? And if you go now to the Rome window, you see all the 1, 2, 3 transactions from Rome are put together in one group, and their individual sold amounts are right there. And then now the summation is done in a window, which is what this plus this plus this, and that's the value you get right here, and it's pasted across. You see this analogy, this. So this is the aggregation being reported on each row in the window. Same amount because it's the same window. The London window has 2 rows, and you see the details of the transaction right there, and then the aggregation is added on it. So that's exactly what we want to do. We want to preserve all these 121,317 rows and then show this aggregation. And the aggregation we're targeting is what? That summation amount of product quantity purchased. And this is it right here. So this one we need a group by, but that's not what we want to do. And there was a clue also right here to do this per sales order ID. See? So it means that just like we did the per city analysis right here, partition by city, we need to include that in this. We have to partition by that. This right here. So what I'm going to do on this, I'll just modify this part right here. Where is that summation? Instead of using it in an aggregated environment without the window, which is going to be this one, which we need to go by, I have to transition into the window environment. And how do you transition an aggregate function onto a window environment, always remember this is the over clause. The over clause is what defines the window. Right. So we are doing the sum of the order quantity over this window. And since if we don't partition by, it means that we are summing across everything. But the question was very specific. We have to include one row per this. So we can partition by that. If not, the thing is just going to sum all of them. Right. We can make this interesting by just doing a partition by. So all orders that have the same sales order ID will be placed in one group. Missing a by right here. Partition by this. Now, let me execute this query. I don't know how long it's going to take. In fact, let me share this with everyone so you can run it. Let's see how long it's going to take. Just copy that, put it on a new query window, connect to AdventureWorks 2022, and then just execute. Let's see how long this is going to take. And the first person to have that executed with the results showing up, just let us know.
Mine is done. I have the same amount of columns as earlier.
Yeah, that's a very good thing to do. Right. So we're keeping track of that original amount. See, mine is still running, so it's a server issue. Mine. Let me see how many minutes I took. So mine ran for 30 seconds. So yours should maybe be less than that, maybe 20 or 15 seconds or something. Right. So this, and the good news is that we are keeping that same number of rows. This is very important. I really want you to see that if we had gone the other way by using the group by, the structure will be different. It is not going to be looking at the groups. But if you want to preserve the total number of rows, switch it to a window function, and that's the concept we just did. We added the over clause. What query did I execute? Yeah, with this one, we added the over clause. Did I share the right query? Just a moment, let me go back to it. Yes, I did. Yeah, the right one. So this is the correct one. And then if we do partition by sales order ID, you have to understand that there are windows right here. This is one window. You have to focus on the sales order ID. As long as you're having the sales order ID, you're dealing with the same opener. This one is this, all the way to this. Yeah. This, same. Okay, I think the first one I did was correct. This is a different window, so I'm going to stop right here. This is the partitioning was done by sales order ID, so this is one. Right. And one thing I can do, I can return the individual, because this is now the aggregated. I can go back to the query and report the original order quantity without aggregation over the window, so that we can just, see this quantity right here. Let's add that and then run this query. Let's see how long this will take. Okay, now I can zoom into a window. I want to do so. I want to check this. Is it correct if we add all of this? Does it give us 26? Or maybe I need to do, let me just check. Right? If this window is correct right here. Oh, this second one is easy. Yes, this one right here, the same window. So this plus this gives you 2. That's why the 2 is repeated across the board. Let me go ahead and check this. Excel will never go away, and most data analysts use Excel to fact check the analysis. This is very important. So make sure your knowledge of Excel, you keep working on it. Excel is never going to go away. I just want to check something. I want to sum up this and make sure it's 26 for that particular window. So that's the partition ID, the sales order ID. So we do this a lot. If I copy that, it's not. Let me just go back. So if you want to copy with the column names, right click on this intersection when you highlight the zone, and then you do copy with headers, right? So that it gives you the names of the columns. So always use Excel to fact check. What do I want to fact check? I want to fact check this. This is a window which is partitioned by sales order ID. So all of this is the same sales order ID. This is one window. So summation over a window simply means sum of all the values in that given window. So I want to use Excel to test if the summation of this will equate to 26 as reported right there. So what am I summing up? You see, I have to put my cursor right there and then go select the region to sum up all the way to this. And then once you have that, click on enter. Yes, it gives. So this is what I was fact checking this, and it's pasted across. Why 26 across every single row? Because it's the same window. So a window function returns an aggregated value on each row of the window. You see that in the Paris window, the sold amount 300 and the sold amount 500 were summed up to give you 800, and that 800 was reported for each row in that window. Same thing on the Rome window, 200 plus 300 plus 400 is summed up to give you 900, and 900 is reported for every row in that window. So in our analysis, we are partitioning by sales order ID. So I cannot just jump into this analysis and I'm just, I have to explain it per window as defined in the question. The summation was done on the order ID, on the order quantity, while partitioning on this. So that is a very useful aspect of the result. You have to analyze by zooming in per window. And a window is defined by what? The sales order ID. See, so this is one window, same sales order ID. The window ends right here. If I extend it, it's a different sales order ID. That's a different window. For this one, there's just 2. This is actually simple. The quantities are 1, 1. Summation gives this. See, and you go to the next window. As long as you're seeing the same sales order ID value, you're dealing with the same window. This right here. Right, and the summation of all of this will give this. Right, and you can just copy this highlighted segment, take it to Excel. So Excel is very important tool to fact check things. I want to fact check this. I encourage everyone to always do this in your logics before you start sharing with colleagues. Right, it is frustrating when you do something, share without testing, and then other people go discover loopholes in your logic and they call you back and say, hey, what did you do? This always make it a habit to check things before you send them out. Right, so this is it. Now we understand this. That's why this document is very important. This picture right here. See, in a window environment, the aggregated value is reported for each row in the window. First thing you have to understand, in a window environment, every row is reported. You see each row. Nothing is hidden. If you zoom into a window, you're seeing the details of that window. This is very, very powerful, right? So once you understand that's the direction the analysis is going to, just switch to a window function. If the details need to be seen, it's a window environment. If you want to do summarization, grouping level, it's a group by. Very, very important. Remember the last general revision we did, a student was purposely requesting for window function. You know why? Because a lot of interview questions have been around window functions of late. So I did promise to come back. I will organize another session. We're going to go over window functions. It is typical in interviews. Right? It's a little bit tricky, but once you invest time on it, you will become an expert in this. Right? There's one part I skipped where we had the salesperson. Right? So some transactions you might see some transactions where there's no salesperson right here. It's a typical example. Right? See, salesperson. If I go back to the question, there's a reference was made. They knew you're gonna encounter that, so they made provisions for a way out. Where's that question? Right here. So for the salesperson, they knew some transactions have missing salesperson, the nulls. Most managers don't like to see nulls in reports because when end users start using those reports, they come back and ask question, what's the meaning of null? Null is a programming construct. It is easily understood by programmers, not business users. You see? So they've made provisions for that. So if the sales order ID doesn't have a salesperson, then specify no salesperson. So you have two options. Either you see the null, or whenever you see nulls, replace the nulls with no salesperson. So all of these nulls on the salesperson, we need to replace them with no salesperson. Business users will now be able to understand this report. But if you just put null, no matter how you explain to them that null simply means that transaction had no salesperson, they're still not going to understand. But then you have to build a report not just for the moment, but for the future. Every sales agent that joins a company, you have to explain to them, oh, when you see null, it means no salesperson was involved in that transaction. No, just code it and leave it there. They will see, it's educational, you see. And that's the goal of this question. So I need your opinions. How can we transform that salesperson name so that if it sees a null, you should have this instead? As a data analyst, what strategy will you put in place? So let's go back to the query. Our target is this. This is where that thing is coming from. When you see logic like that, it's the case statement. Or you can use the if function. It's just one condition to be tested. Right. So if I want to type in the case statement that's maybe too long, I can just go, and this is the logic we're targeting. Remember this one. So I can just put an if function right here. If function, right? It's the same thing like a case statement. And what are we testing? If this right here is null, remember the test for a null is what is null. If this thing right here returns null, that's the test. You cannot put equal to null. Right? Always remember that you cannot put the test for the null is null. So if this combination of the salesperson first name and last name returns a null, like what we see in these zones right here, then what should you do? So if this is null, that is the correct thing to put. If this is null, then what should you do? Remember the if function carries a condition. That's the condition we've written. And then show an outcome, which is the true outcome. Then go ahead and show us the combination of the name. Is null. Now this one should be is null. That is going to give null. Then we are showing this. Sorry, I have to reverse this. If that is null, then show what the business want it to be. It should be this, right? So if this evaluates to null, then show us this. This is what you want to put. Else, the else part for the if function is just a comma, and you put the next one. The next one will be, this is becoming long, it's going to be this concatenation. It means that person has a first and last name. So show us a name. That's the meaning of else. So if this is null, show us this. Otherwise, show us the concatenation, which is what combination of the first and last name. And usually when you get to this point, the I function, you start seeing that you probably missed out a closing parenthesis. Right. Let me go ahead and add one right there and see. Yes, that was the case we're missing. So usually it's just to make sure that the number of open parentheses is balanced with the number of close. Open is what? 1, 2, open 3, and then close should be 3. See, I even missed one. So this is very important. I've exaggerated this. Open parenthesis we have. Oh, this is the problem right here. I if right. Okay. I function. So we are testing. Let's check out the open parenthesis one more time. 1, 2, 3, and then the close parenthesis is 1, 2, 3. Oh, I still have an error somewhere. Okay, so the error is right here. I can just address this. So right here, this is the opening of the I function. The concat function should close right here. That's a mistake right here. See that? So this is the concat function, right? It has the open parenthesis and the closing right here. That's what I failed to put. So this is the if you look at that name, yeah, this is the concat function which combines the first and last name. So if this combination of the first and last name is null, we are looking at these scenarios. What should you do? Show us no salesperson. So there will be no nulls when we execute this. Show us no salesperson. Right, and then we continue. Otherwise, give us the concat, the actual name. So I should dismiss one of this and let's balance that out again. Open parenthesis is 1, 2, yes, and 3. Closed parenthesis is 1, 2, 3. Balance. This is always a problem when you're dealing with nesting functions. You're putting one function into another. You always have to make sure you balance the parentheses. It's a very simple thing I'm showing you, but it's going to save you a lot when you start working in companies and you invest, nesting logics into another logic, functions, another function. Simple test, make sure you balance that out. Again, let me share this. While this is running, let me share this. Please run this version. Now we've been able to take care of those transactions, sales order IDs that have null on the salesperson. We've now been able to perform that transformation so that if the nulls are encountered, give us no salesperson. Right, the ones without nulls show us the actual name. That's the logic we've simply applied. And you can still solve this with the case statement. So case, when this is null, then this, else this. If you use the case statement route, this is what you get. Right. This thing is still running. I've added one extra logic, so it's right now. So previously had 30 seconds, now it's gone up. So see, adding a logic onto it increases the time, right? Because he has to do that investigation for all the 121,000 rows and something. So he's investigating if the first and the last name for the salesperson is null, then we don't want to see null in the result. You want to see no salesperson as a value. Otherwise, that's in a scenario where the names are actually there. Show us the name. Please, can somebody run that and tell us how many minutes they had to execute? So I've just modified one column, the first and last name of the salesperson. So at the end of the day, you notice that knowing these functions is not enough, but then understanding how to use them in problem solving, that's where the real concept comes in. There's the business application, business intelligence process of it, right? So it is important to know these functions, right? Then using them in problem solving, that's another very critical aspect. Mine indicates that the query has executed. Let me project the result is this, right? And now if you go in your results, I'm focusing on the person type, all those areas where we're seeing nulls. How am I getting? Oh, sorry, I used the wrong column on that. Right, so this was built on the wrong column. So just a moment, let me project this again. Salesperson name, now it is giving me blank instead of giving me. So I am getting the blank. You see, this version now for the sales, I'm getting the blank. Okay, I'll have to modify this logic. Let me go back to the question. So instead of using the combination, I will just use one part of it. So instead of using this combination, I'm going to split it out. All right. So if salesperson or this is null, so I'm kicking out the concat process for the first one. I'm testing if this an expression of non-boolean. Let's test one of them. I think one of them will be okay. So we're testing if this is null. So the first name is missing. I'll do the second one for the last name. But if the first one works, that's still fine. So if this is missing, then we get no sales. Otherwise, or I can do both. I can do for the first name and I can add another condition for the last name. So if the first and the last name of the salesperson is missing, so I have to do it separately. First name is null, then last name also is null. The last name is this one. So first name is null or last name is null. You know the problem with concat, if you concat null and null, you get something, you get a null. But then the system was having a hard time to understand that process. So that's why I'm using the actual column name separately. So if the first name is null and the last name is null, or to make this relax, I can just put an or right here. So if the system is going to check, is the first name missing or is the last name missing? See that? So the first test is the first name missing for the salesperson or is the last name missing for the salesperson? This is not the condition. So when it's missing, then use this, right? Otherwise, show us this combination. So I don't want to use the combination in the first test because it's like concatenating null and null, right? first name and last name, they are missing. Concat null and null, you have something funny. Let me go back to this. Let me just put it on a new query window so you can see what was happening in that our code. If the first name is missing, you have null. I want to explain what happened. If the first name is missing, you have null. If the last name is missing, you have null. But remember, in a concat, what do? We use first name is missing, and then we use a string to separate first and last name. And then you put a null. So there was a loophole in our logic. This is what we are using. Now run this and see what we get. We don't get blank. See, in the first analysis, I was using this and testing. If this is null, so select, I want to explain what happened in that logic so you understand. It helps in problem solving. So select, this is what I did, if function. So if this is null, this is what I did. This is not null. This returns an empty string. So I was testing if this is null, as a condition, give me no salesperson. Let me just copy that stuff. This to see. Just a moment, let me reduce this window so that I don't get confused. So give me this. Otherwise, give me this. Even the combination of the first and last name. See? So we've just tested that this right here is not null. It gives you blank. So blank is, see, this one is never going to be compatible. So what I've done is that I've now decongested this process and I'm testing individually the first name and the last name separately. That is a better way to solve that. You see, my strategy is not working. It's giving me blank for those persons that have missing salesperson information. I'm getting blank. These blanks should instead give me no salesperson. So I've gone now, I'm decongesting the concat function, I'm removing it, I'm using the column separately. So if the first name is null or the last name is null, then give me this information. So it's a simple test. That combination which gives you a blank, or you could go back to that query and modify. Instead of using is null, you can put a blank like this. That query I just sent to you. You can maintain the concat, you put the blank. I'm still not very happy with that. Let's better use this option. This is much more easy. We test on the first name and the last name separately. If you're missing first name or you're missing last name, this is what you should get. Otherwise, your first and last name are present, then let's go ahead and concat them with a space. See how this strategy, let's go ahead and let me share this first. And then we're gonna run this. It's a typical business things, especially when it gets to building reports. I encounter this a lot. So let me send the query on the chat room. Okay, so check out the last one I just posted. And now if we execute this, so this is going to be a better version since we've separated the first and the last name. We're testing them separately. Still running. So check the output window, check the chat message for the new query. So this one that splits out the first and the last name, test them separately. This is going to be a much more better outcome. Right. And once you hit your target, you're going to know. Right. So we should see no salesperson for the column salesperson name. If the name is missing, that's first and last name is missing. That's why we're testing them separately. This is null or this is null, then give us this. Otherwise, go ahead, since the first and the last names are available, go ahead and concatenate them. Right. So I'm just waiting for this to load and display the results so we can compare. Anyone has a result for the last query? Mine is still running.
Mine got executed and it was correct, the output.
Okay. Yeah. So in the correct output, you should be able to see the no salesperson under the salesperson name column for those transactions involving no salesperson, instead of seeing null like we had before. So I just wanted to understand the whole purpose of this exercise was to do that. Right. So let me wait and see if this I'm going to solve question 5 and then I will give you 6 and 7 to solve so that we can now go to today's topic. But we're going to do 5 together. I think as you're building this together, you're understanding what was, the objective of this question is heavily into the case statement, right? Okay, let's go to question 5 while that is running. So in this question, you're going to be working with the purchasing vendor table, right? And I'm just going to take you to I want to make it a habit of you checking out the data dictionary. Right? Just be aware that it's a document called data dictionary, which gives you all the tables you have in the database and a description of every single column in those tables. So it begins with a schema. For example, I want to check out this table. The table name is vendor, but this table is found in the purchasing schema. So I'll first of all have to locate purchasing schema. I'll start on the schema side. Once I see purchasing, I stop and I go to the next table side and I have to see vendor, and then I should be on the right table for the question. So make it a habit, right, of consulting this data dictionary. It helps you to, okay, this is the purchasing, this is where it begins. Right, we are looking now on the table side. So once you locate the schema, switch now to the table side, the table. We are now looking at vendor. So when we see vendor, we stop, and that's the right. So right here. Now, when you do a select star from purchasing.vendor, these are the details of the columns you see. This gives you more power as a data analyst. You understand the business implication of the table right in front of you. You can see the description of every single column. See, that's the power. So the business side has been covered. Now you can focus on the SQL side and make sure you deliver the result. An effective business question can be solved when you combine the business knowledge and the SQL knowledge together. You blend it. This is very, very important. Sometimes you have problems in solving questions because the business side is not fully understood. Taking too long, I'm probably just gonna abort this process. So this, when this button is red, the query is running. This has been going on for like 6 minutes. Right. Then abort this process by clicking on this. It says cancel executing query. I'll click on that. Cancels the query. See, the feedback is right. The query cancelled. Yeah, that was taking too long. Right. So that we can go now. I want to free that usage. We can go to the next question. Yeah, close this. Let's go to 5. We're gonna do 5 together, and then I'll give you an extension to do 6 and 7. Right. Tomorrow, if you have any challenges, just let me know. Let's address that. So let's go to 6. So once you've started reading a question like this, and question 5, sorry, talk about this, just stop right there and do a select star. This would be the investigation we're going to do. Select star from, we are connected to the same database, Adventure. I'm just going to run this, and I've shown you how to navigate your way on the data dictionary to find out that table. This is the zone. So every single column you see on this table, you know exactly what is displaying. Business entity ID, you can go back and read. This is a primary key for vendor records, and they tell you how it's connected to the other table. See, what is the account number? The next column is account number. You can see the description right here. Vendor account, this is identification number. Then that is a company name. The credit rating, right? What is credit rating? 1 means superior, 2 means excellent. It's similar to the credit score stuff we did in the previous project. See, right? And so preferred vendor status, everything is right there. Active flag. This table is a critical one because it has so many abbreviations. Right? If you're working as a data analyst, they just give you this. You don't know what this is all about. Just 1014, funny numbers, see. But then the business side is properly documented. It gives you this. So you are better armed to solve any question involving this table, right? So data dictionary, it's very important to explore, right? Not every company has this document, unfortunately. You have to reach out to the project owners and ask for clarifications on these coded columns, right? So now let's get to work on this question, right? So in A, we want to show each credit rating by a count of vendors, right? So sometimes reading a question like that, you don't really understand each credit rating by count of vendors. So show me, for example, credit rating 1. Tell me how many vendors have credit rating 1. Credit rating 2. How many vendors have credit rating 2? That's the meaning of that question, right? And again, if a question is not understood, always reach out to the manager or the project owner and ask for clarification. You're not asking the SQL side on how to do this, But what are you expecting to see? This is very important. Show each credit rating by a count of vendors. Each credit rating, first exploration I would like to do, how many credit ratings do we have available? If you do it, select distinct on credit rating, right? This is a case where you're going to be using the group by, right? Because I want to show each credit rating and how many vendors or how many companies have that credit rating. So select distinct credit rating. All right, this is not a scenario of a window function, right? The answer will be strict, tied to these 5 rows. So whatever analysis you do, you get 5 rows. You cannot You start this 5 rows. Those are the 5 distinct credit rating. How many vendors have credit rating 1? How many vendors have credit rating 2, 3, 4, 5? You see, this is exactly what we want to see. See that? So there is definitely need for a group by. So that's the first exploration right there. And then you see, we now go to the actual question. Don't just make it the habit of getting the question. You just want to provide solution. You're just solution driven. No, explore the question, explore the table, and then you build gradually. That's always the problem. After working for a while in a company, I've learned this. You begin solving equation by exploring. Of course, most of our queries run on tables. Explore the tables involved. Join them if you need to join and explore them. Don't do question solution. Now, explore things, build up your strategy, and then you hit your target. Right. Okay. So in A, show each credit rating by count of vendors. Now back to this table, I will be showing each credit rating. Now I want to move to this dimension, each credit rating. I now want to do count. How can I count my vendors? What is an appropriate business approved method of counting the vendors? Data dictionary will help you in this. Each vendor has a name. Yes, you can decide to count on the name. Each vendor has a business entity ID. You can decide also to count on the business entity ID. This is primary key for vendor records. We are on the vendor table and it's a primary key. I always like counting on primary key columns so that I don't do any distinct operation on it. You can decide to count on the name of the vendors, see, or you can count on the business, that's the company name. You can either choose this or this. And these are fully backed business strategies. Let's begin with the first one. Count the vendors by counting on their business entity ID. Each vendor has a name, a unique name, of course, and also has a unique business entity ID. So you can choose whichever one you want to do the count. Right. And this is what? Number of vendors. If I run this query, first thing I want you to realize that we are in this dynamics. Where's that stuff? I lost that stuff. I can go back and pull it. This is very important. The window function diagram. First thing I want you to understand that we are not in a window framework. We are on the aggregate function normal environment. How many credit ratings do we have? Our exploration gave us 5 credit rating. Is that 5 or 4? Right here, execute. Our exploration gave us 5 credit rating. So we are in this 1, 2, 3, 4, 5. And then the aggregation will now be done for each row. So the colors is no longer be green across, giving you one aggregation. The colors will be different because they are different credit ratings. But then we're going to be calculating an aggregate per group. Aggregate functions return an aggregated value for each group. This is very, very important. An aggregate function returns an aggregated value for each group. This is the aggregated value. So this value will be returned for each group. Sorry about that. I had some connection issues. Right. So this is what we want to see. We want to preserve. We don't want to see the individual companies that are in rating 1, rating 2. No, we don't want to see that. We just want to see this aggregated value returned for each group. And this is the process where you need a group by. If I don't put a group by, I get an error. I think by now we all understand this. At this level of the training, this is the 7th week, we understand this. We have an aggregated column together with a non-aggregated column. We need a group by. We need to group by the non-aggregated column. This is it. So if I run this, this is what we get. So in credit rating 1, there are 84 vendors. In credit rating 2, there are 9 vendors. In credit rating 3, there are 7 vendors. Just like that. So this is what the grouping will return. I think I should be able to show you how we can transform this by indicating the individual companies, the individual names of vendors. I want to transform this into a window function. Now, how do you transform this? You have to put an over clause. Since we are doing this analysis per credit rating, let's partition by credit rating. We saw how we use group by credit rating in the previous. In a window environment, this will now be transformed into what? A partition by credit rating. You see this analysis right here. Please take note, we will not get 5 rows in this analysis. That's the power of a window function. A window function shows you an aggregated value over a window. And that window, you get to see the full details of the rows in that window. An aggregated value for each row. This is a keyword. An aggregated value for each group because you're doing a group by. And since there are 5 distinct credit ratings, you get 5 distinct groups, the aggregated value for each group. In a window environment, you get this aggregated value for each row in the window. Right. So if I run this, you will now be able to see that our row, see full details. If I go to credit rating 1, this analysis told us that there were 84 vendors in credit rating 1. I see a list of all the 84. When I zoom into credit rating 1, let me expand it all the way down. You see, this is it right here, 84. I want you to understand group by and partition by. In partition by, you're seeing the individual rows in the window. In a group by, you're seeing the distinct. A distinct will simply, this is 111 throughout. So it takes one of the copy and then just give you 84 distinct. And that is what the group by is doing. So in the group by report, this is credit rating 1, that's group 1. And then the number of vendors is 84. That's the only thing it's going to report to you. One row for each group. Credit rating 1, 84. That's what it reports. In a window environment, no, you're seeing much more details. An aggregated value is returned for each row in the window. Credit rating 1 has 84 companies, and this is the full list of the 84 companies right here, all the way to 84 right there. And then we've counted all of them and report 84. The value is repeated for all rows in that window. If we go now to what? Credit rating 2. How many companies have a credit rating 2? 9. If you go to the window function, run that same stuff on the window function, you go to 2, you're going to see, you see, this is a different window, so it starts all over again. Right, 2, this is it. You see the 9 companies that have credit rating 2. This is it. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 9 companies that have credit rating 2. And that aggregated value, which is what? 9, count of the companies is what? This is a 9. If you go to, and so on. I really want to highlight this. This is very, very important. Right. So let me dismiss this. This was not a goal. Right. This is what we want for that question right there. Right. Your manager will look at this and they will not be happy. Credit rating 1, 2, 3. There is a nicely defined meaning of all those credit ratings. Why should you give people a result like this? They start trying to interpret what is 1, what is 2, what is 3. If you're not in the credit reporting system, you'll not understand that. Give people a fully defined report. self-explanatory. Right.
Mr. Blaze,
Yeah, question. Yeah.
I got a question for A, right? Because I actually used, I saw it on my own, but I used the Windows part of it, the Windows function.
Yes.
But then I used if you use this thing, then it's going to be the same solution, right? Because I used this thing and I got the same output as when you use
Sorry.
just a regular grow by.
Yeah, man, that's a good point. So if I go back and so you use this, and then in this you now force a distinct. Yeah, it will be, but you have to knock this off.
Yeah, I didn't include a name, so
Yeah, that's a good point. Yeah. So because the name is something, no, every company has a different name. So as long as you're removing the thing that can bring differences, right, then you're fine. So let me first of all project this. Now you see that this is just repetition. You see one is repeated 84 times. So now if you throw in that distinct concept, like what is you mentioned, that's awesome. You're now bringing this back to this. So this is what you had, see? And then with the distinct concept, you're doing this, right? But then now this is what we call a performance issue, right? You took the system all the way to this. First, that's what the system will do. See that, and then now it runs a distinct to get to this performance. Two steps, you have a performance issue on that. But if you go through this one-step process and you're hitting your target. So now this is a higher level of SQL. Two solutions can give you methods can give you the same solution. But what is the labor involved in returning that? That's where the performance comes in. See that? So this is good, but I won't recommend you to go through this route. Go through a window function. You have to understand that the first step is to do this. So if you had millions of records, it would do this first, time consuming, before now doing a distinct across the board to get this two steps, two giant steps into one. But then if you just identify how the problem was about aggregation in a non-window environment and you just hit your target, this is a one-step process and you're there. Right. So I always want you to pay attention to that performance issue stuff. Right. It is good from a SQL perspective, that's fine. But now as an expert, we've gone over that excitement phase of writing your first select statement. It runs, you're happy. Now we're looking at, we have to start optimization, performance of your query. Right. So that's a very important remark. And this is also good for documentation. So you actually understand now the difference, the power of this window effect is when you start adding more information. Right. And you see that the behavior starts changing. So if I throw in name, if I put distinct right here, the fact that name is there and is already distinct, it doesn't distort the original arrangement. It stays the same. So you have to first of all start by dismissing any column that is generating that non-uniqueness. Right. So once you dismiss a name, like what we did right here, you get. Yeah, but from a performance point of view, I wouldn't want you to go through window functions before hitting the distinct and then do it. That's the group by. Right. Okay, but that's a good remark. I'm happy. Yeah, it shows this understanding. Right. So I'm gonna dismiss this and this. Yeah, I was talking about this. Right. This is the A part, nicely done. But then I want you to understand where the B part comes in. And the goal of the B part was to show more light on this. So this is A. Let's go back to the question and target the B part. Use a case statement to specify each rating by count of vendor. So it's the same question like A, but we are now making A more descriptive. This is what we've done in A. Let's make A more descriptive, right? Because not everyone will see credit rating of 1 and understand what is it. In that table definition in the data dictionary, we saw this. This is it. 1 means a superior credit rating. 2 means excellent. That's what we want to do. We want to use the case statement to make this more descriptive, right? And so the only thing we're going to be targeting in this B will be the credit rating definition. That's when we can throw in our case statement. Case when the credit rating is 1, what should we want to see from a descriptive point of view? Superior. Right, that's the description of the meaning of 1, you see, so that our experts can also understand this. Right, I forgot to put it then. The when carries the condition, the then carries the outcome. Right, and you just have to no commas. Commas will come at the end to separate the next column. You just go to the next. So when credit rating, I can just copy this and we edit as needed. That's just a lazy strategy. This is excellent. Excellent is 2. So when this is 2, we get excellent right here. And copy this and take it to the next line. Sorry, we have to take a break after this. I've kept you guys very engaged on this. This is 3. This is this. Yeah. And then when it is copy that again. I'm just being lazy, but that's fine. Once you understand what you're doing, nobody cares your steps, but care more about the final outcome. So 4, we're gonna get average. So this is a very meaningful analysis we're doing right here. I will go ahead and define everything. Right. It's very important once you're giving those definitions, define them the way they occur. So this is 5, and this is this definition. Right. Now you can throw in an else if in case you've missed anything or some nulls missing data start showing up. I want you to return a null and then you end the process. Always remember. And then this, we could still maintain this as the same column name as credit rating. And then we put a comma right here to go to the next column. See? This is it. This is now much descriptive. This takes me back to question 1. Explore the table below and tell me the errors. I remove this and I remove this. There are 2 errors blocking this query from running. Explore the query and fix the errors. And now you understand in the case statement, you have to terminate it with an N operator. That's the first error fixed. Second error, this is a non-aggregated column credit rating. This is an aggregated process, so we have to go back. This is a revision of the first question we did today. Go back, credit rating, execute. See that? Now this is more descriptive. Compare this result with this one. Let me run both of them. See how your manager can challenge you after the first one. You submit this. See, this is not descriptive enough. Do this instead. And that's just a case statement. You cannot do without the case statement. This is very, very important, guys. Like, yeah, we're gonna take a break. I'm gonna share this too. We take a break, and we're gonna continue after the break with the actual. So as an assignment, you will continue with the this is C part using the case statement. Show the preferred vendor status by a count of vendors. Yeah, you can do this part. So 0 means not preferred, 1 means preferred. So it is stored in one column called preferred vendor status. You have to split it out into 2. Let me just go ahead. So it's a continuation of this, and it's going to be a count process. So this right here is C. So if I put a comma, it's going to be a counting process. We want to count those that are considered to be preferred, and then count those that are not preferred. Please understand that this is stored in one column. And so for you to apply the counting process, you have to split that out. So again, you will need a case statement. So case when the preferred vendor is equal to 0, preferred vendor status equal to 0. That's for what? Not preferred vendor, not preferred. So case when preferred vendors equal to 0, then this preferred vendor, else let's get a null. So this is very important, and then you end the process, so that when you apply the count function on this, you're counting the not preferred vendors. See that this is a subset of this column. This column has two parts, preferred and not preferred. So if I now wrap a count function on this, this will be counting the not preferred vendors. Right. I can now introduce my count function on this logic. Count all the way to this. That's now a count. See? And if I do the opposite and make it equal to 1, I'll be counting the preferred vendors. So just switch this. This is now a different column. Remember, originally we had one column where the 1 and 0s are stored. I'm now extracting them separately. When the preferred vendor status is equal to 1, the system says that this is a preferred vendor. Go back. Preferred vendor. This. Right. So this count is strictly for the preferred vendors. And I'm exploring the power of the count, not counting nulls. Right. And this is it. This does not alter the group by, because this is a counting process. I now have 3 aggregated columns together with 1 non-aggregated column. So our group by stays the same. We've added aggregations, not on group columns. So this is very important. So out of the 84 vendors in the superior credit rating, 9 have not preferred vendors. Let me go back now and add the names. For the column names, I can now put this not preferred. These are the number of vendors not preferred. You see, this is a breakdown. This is a very powerful thing I'm showing you right here. You see this a lot in businesses. And then this is now a new column called that, and this accounts. The idea of targeting a column and splitting it into 2 parts and doing the count separately is very, very important. So I can now add this number of into that analytics. This is a number of not preferred vendors. This is the number of preferred vendors. The ability of using a case statement to target a column and split it into 2 parts. Then apply aggregation on the logic. This is very powerful. This right here is it will take your analytics to the next level. So out of 84 vendors in the superior credit rating, 9 are not preferred vendors, while 75 are preferred vendors. Maybe if I want to make this more interesting, I can add that vendor stuff, right? So this is tracking the total number of vendors. This is usually in a report. This is a metrics, right? This is what right here. And each time you add this and this together, they get this. This and this together always get to this. This and this together get this. See, this is a very interesting area. All the 7 vendors with credit rating of above average, all of them are preferred vendors. All right, this is very powerful analysis we're doing right here. Okay, so that's the end. I see I'm going to end it right there. I will make sure I provide you the script immediately after the class. You continue and do 6 and 7. Okay, let's go ahead and take a break. Let's take a 15 minutes break. Hey guys, are we back?
Yep.
Okay, so I'm going to save this script and I'll send you a copy of this. So we've solved all the way to question 5, and you just have to work on 6 and 7. It's going to follow the same logic. It's mostly built around the case statement, right? And this has been an interesting exercise, right? So any
Do,
question?
do you mind sending the solution for
Yeah.
5C in the group chat?
Okay. Yeah. Oh, okay. For 5, just a moment. Let me go to 5. So on 5, just did we finish 5? We did C. Oh, the C part. Okay. Yeah. This is a C part. Okay. Please, this logic of splitting a column and counting a part of it and splitting and counting another, this is very important. Right? It's the logic you see showing up in a lot of business processes. It's good to understand that. Right? Next lab, we're going to see questions on that. Right? So I'm going to close this. I think we will address the 2 topics for today: views and subqueries. Then tomorrow we're going to look at variables and stored procedures. So for today, I think I have a script prepared for this. Right? In one of the exercises I shared, it talked about a view, right? I don't know if you all remember that there was a question with to do a select statement on a certain view, and when you hear about a view and you go search it on a table, you're first of all on the wrong spot. There's a separate folder for views and a separate folder for tables. So this is week 7. The last 6 weeks we've been looking at tables. So we've been targeting this folder. In every database, we target this folder, tables. I want to take you to something different. That's the concept of views. So a view is a virtual table, right? These virtual tables are built from the physical tables which are stored in this folder. So views are virtual tables that have been created by combining tables in this. And you understand that every table occurs on its own, single, separate. You may have a business question that combines multiple tables and you want to save that copy as an object. That's what the concept of a view. So a view is basically a saved query. If you notice, we haven't been saving our queries inside SQL Server itself. We've been saving our queries outside. See, these are all saved queries. See, we haven't actually run a query and then save it as an object inside SQL Server Management Studio. And that's the power of views. A view is a saved query. It's a virtual table built from other physical tables. So let me go to day 1. This is 7, day 1, views. This is it right here. I'll just open that. Let me go to the shortcut, please. So let's address views. It's going to be straightforward. And then when we're done with that, we address subqueries, which is also a simple concept. Day 1, views right here. Open. And you can also check the PDF document. There's a PDF document that explains this concept. It was also provided. Week 7 lecture notes. At the top of this PDF document, you have the concepts covered. Last time we talked about system functions. I gave you this document, but then I skipped views and subqueries. These 2 topics we skip this. We're going to address them, right? So you can just go to views right here. All the definitions you need are provided in this PDF document. Also, it's available in this SQL script. In SQL, a view is a virtual table based on the result set of SQL statements. A view contains rows and columns just like a read table. You can select star from a read table. You can also select star from a view. So your select statements can also run on a view. And these definitions or these terminologies are important. Physical tables versus virtual tables. So the physical tables are stored in the table folder. If you go to any database, tables folder, that's where the physical tables are stored. Some people call them permanent tables, some people call them real tables. What about the virtual ones? The virtual tables are stored in the views folder, this folder right here. Right, this is very important. Right, now how to create a view? Let's see how we can create them. Of course, we use the create. When we are going to study how to create databases, how to create tables, we're going to come back to this create statement. The create statement is the statement you use in SQL to build things. To create a database, right, you have to type create. You put the name of the database you want to create. First, create. This is the part I left out. We're going to come back to it. Create a database, maybe Wells Fargo. Or create database MTN. All right, this will create database MTN. I want to, after creating the database MTN, I want to create a customer table containing the customer information at MTN. This is create table customer, and then now this is the part I'm going to skip. We'll come back to it. The columns, you define them inside this definition. Right, this is the process of creating a database. The process of creating a schema is also going to be the same. So this is the part I owe you. I have to come back to this. The schema, by the time we get to this, you understand it because we've done the heavy lifting. I want to create the schema call, maybe calls something, right? And whenever you create a database, you connect to it before you proceed, right? Create a database, you connect to it. This is always going to be the and then you create the tables, create schema calls, proceed. So everything I've used right here, that's the framework of a create statement. I'm going to come back to that process later on. So to create a view is the same process. You need a create statement, right? And then this is how that process is going to work out. So we're going to connect to the Northwind database. We have this database, connect to it. And then next, we use the customer table. That's what we call the physical table in this case. You can do a select star from a table. We're going to use this table to create a view that's a virtual table. I'll keep it simple from beginning, and then we start making it a little bit interesting. So ignore this one code right here. Ignore that line. Let me dismiss that. You know this. If I show this to you, you know what this is all about. So the only thing we're going to be learning on views is just this one line of code you add. So if I remove this line of code, I am just running a select statement on the customers table requesting to show only customers in Brazil. This is it. That's it. It's a select statement. This is what we've been studying the past weeks. We know this. And the only thing we're going to add to this query to save it is the line we add above. Create view Brazil customers as this definition. That's the scope of the view. So this table right here is a virtual table. It will be stored under this name, Brazil customers. What you see in this query is what will be contained in that table, that virtual table. If you specialize on two columns, you cannot get anything out of that. It will only be two columns. So this Brazil customers is a new table that has been created with these two columns only. That's the concept of a view. So this query has been saved. If I now do select star from Brazil customers, I will get this table. So you have to understand that a virtual table uses a physical table to create it. See, this is a virtual table called Brazil customers, which is built from this physical table call customers. So physical table customers, you will find them in the tables folder of that Northwind database. If I go to Northwind, it's been a while we've not explored this database, Northwind. If I go to tables, I will see the customers table right here. It's a physical table. It's stored in the tables folder. If I go ahead and execute this, I'm connected to Northwind. I'm creating a view called Brazil customers. If you go to these tables, you're wasting your time. You'll not be able to find the Brazil customers. It is not a physical table. Brazil customers is a view, it's a virtual table. You'll find that in the views folder. So you have to go to this one, expand on it. This is it right here. This is very, very important. And just like you can do select star from a table, a physical table like what we did right here, you can also do select star from a view. I think that's what follows. How to retrieve data from a view is a select statement. This is us doing a select star from the Brazil customers view created above. And remember those two columns I mentioned, that's the only two you get. This table, the original physical table, has many columns. But for the Brazil customers one, we choose just two customers in the two names, in the two column names in the definition. And that's why that's how we created these Brazil customers. And guess what? Each time you call that the virtual table, you only get access to those two columns. And this is one very important use case scenario for views. Views help companies to hide confidential columns with very, top level security information. So just imagine a data analyst has joined the company as a contractor. They want you to build reports using the customers table or any other table. And there's some sensitive information on the tables that the person is going to use. If I give you access to the full table, the original table, you see everything in that. When you select star on the column, you see all the, on the table, you see all the column. I can restrict the columns and just put them on a different view, build something different, and use that base table in the, see, and only call just the columns I know you need for your analysis. I want to join a company, and this is exactly what they did to me. All right, they didn't give me access to their tables. They gave me access to a specific views. And that view contained information they've joined from other tables put together with specific columns that I need for the analysis. And they say, use this view to build us a report. See that? And this is the power right here. All right, this could be joining multiple tables. We're going to see examples. All right, and everything's packaged together and then given to you. Use this view to do the analysis, to build us a dashboard. Only that view you're going to use. You don't have access to any other physical tables. You see that? So it helps in that regard. And for data analysts who are also building dashboards, this is also a very interesting practice. You're building a report, you want to combine maybe 4 or 5 columns, or 4 or 5 tables. You combine all of those and you save them as a view. It actually stores them. You see, companies like this, by the time your contract is done, this query you used to build the report should not stay on the laptop. It should be on the server. So when you create things and you save them on the server, it's more powerful. Others can use it, others can access it and use it. So whatever you create and store in the tables or in the views, and this is a server, every other person can see. We're all connected to the server, we can see it. But if this query resides as just a SQL file on your laptop, it's accessible only to you. So when you have that critical query you've built by combining different tables, you can make it a habit to save it on as a view. And once you save it on the server, you see, others can access it. In this Northwind database, this database came with other views. See, this is not the only view in this folder. This is the one we created. There are others that are available. We don't even know where they're coming from, but they're right there. They came with the application. That's how you can join a company and you want to perform an analysis. They tell you, okay, no, we have that information already. Just use this view. Other colleagues will tell you, no, use this view. It has everything you need. See that? So you have to understand the power of views. Tables exist separately. Every table is built to capture a particular information. The products table will have product information. If you want to build a report that needs product information, customer information, sales information, you combine all those tables and you can then save them as a view. That's the power of views. You can combine different things that under normal circumstances should exist separately. You can now combine them into one and save it as an object on the server. That's a view. All right, so going over what we've covered so far. First, location. Views are stored in the views folder of any database. Open any database. The moment you see tables folder, directly below is a views folder. On any database, let's look at HRO. Expand on HRO. Go to tables, directly below views. Right. And if you've not created any view, the folder will have nothing. See, this has just one view, department location. This movies database. Let me look at something we created of recently, the Windows Function Lab, the one we did during Lab 6. No views was created in this database. We have tables, of course. These are the different tables we created. You have any views, expand on the views folder, nothing. No view was created. So there's a huge difference you have to understand. Physical tables are stored in the tables folder. Virtual tables, which are views, are stored in the views folder. How do you create them? Build the select statement and then just add this line on top of it. We know this. It's just to now do this. Every view should have a name. In fact, every object you save should have a name. Create. This tells the system what you're creating. It's not a table, it's not a database, it's not a schema, it's a view. Create view. This is the name of the view, and then the AS keyword follows, and you just add this code. All right. So that's how you create. How do you retrieve data from a view? It's a select statement. Select star from the view. This is a view. You see, this is the original table that view was built on. See, the original table has all the columns. The view has just the columns you included during the creation process. These are the two columns. Right. So create. How do you retrieve data from a view? Right. And there's another part. How do you alter a view? Alter a view is to make changes to a view. The manager wants you to add more columns to the Brazil customers. This is how the view is. How do you change this view so that you have more columns in it? That's what the alter statement for. All of these extra statements, I'm going to create a session, we're going to discuss them. Like create, alter, update, delete, truncate, drop, all those statements, we're going to address them. Right. So if you want to alter a statement, you simply replace the create with the alter. You go back to this. Create is when you're building it for the very first time. And guess what? If I try, I didn't mention it. If I try to execute this again, I get an error. Why? Because the view with this name already exists. Maybe some of you have experienced it. Execute again, you get an error. No two objects can exist with the same name on the same server and schema. If I go to the Norton database, I just showed you that we already have a view called Brazil customers. If you try to execute that code again, it means you want to create another copy of that view with the same name. It doesn't allow that. See, views, we already have a view called Brazil customers. If I try to execute this again, it fails. So you all need to just run it one time and that's it. So you understand that if I now put a comma, I try to add a column, I'm wasting my time because I'm on create. The same name is there. So how do you modify a view you've already created? It's now the alter statement. So the alter statement allows you to make changes on an object that has already been created. It could be a table, it's going to be the same thing, alter table. In a view, we alter the view. Now we can add or make the adjustments. See, we're now extending, we bring in the contact title, the address, the region, the phone. We've added 4 more columns to the 2 original columns we had. And see, if I put a crate right here, it's not going to go through because this already exists. See, it's already giving me an indicator. There is already an object named this in the database. I'm wasting my time if I force it. See, the system rejects that because if you look at, I'm still having the 2 columns. So this crate has to be switched to an alter, right? And on the alter statement, you can run this as many times as possible as you want. It doesn't mean every time it will be added, it's just gonna implement the change. So that view has been altered. You see, with the alter statement, you can run an alter as many times as possible, as you know, and do so many changes. See, it gives you no restriction as long as you're on the alter statement. You can do. I can put a comma and add another column. Now these are the changes. It is reflected immediately. These are the 4 columns I added. See that this should be on alter. These are the 4 columns I added. So once you execute it, it does the additions, the updates you made. I always want to show, okay, let's just talk about the drop so that we have the full picture. That's how you make a change to a view. You switch to alter. And then how do you drop or delete a view? How to drop? It's easy. You can right click on the view. There's a delete button right here. If you want to write the code, it's a drop. Drop. What are you dropping? I'm dropping a view. What is the name of the view? This is the name of the view. This is the view right here. Guess what? If I execute this command right here, I'm telling the system I want to drop. What would you want to drop? Is it a table, view, schema, database? No, it's a view. And this is the name of the view I want to drop. If I execute just this line, that's the equivalence of deleting. So that view has been dropped from the views folder. It's right here. It's just the carcass of it. If I just refresh this folder so that it updates, see, it's gone. Receipt customer was B. It was directly under this alphabetical before you go to the C part. It's gone. We've lost that view. But then the original table of where that view was built is the customer's table. It's right there. The statement said drop view, not drop table. If I want to drop the customer's table, it will be drop table, then I put the customer's table. And of course, when you drop that table, it's gone. Don't do that. All right. So I think I've taken you on the full steps involved in the views process. Where to find views? They are on the views folder on any database. You find the views folder right here. How do you create views? You simply build the select statement. It's a way to save your select statement. Build the select statement and then add this line to it. That's all. So if I want to see the Brazil customers is gone, it's no longer there. I can take this all over again. Let's create a view from the customers table and let's make this view hold only the Brazil customers. This is me putting the statement to achieve that and just running the statement. See, it doesn't get saved anywhere on the database on the server. By adding this line, I want to save this output, which has 2 columns with 9 rows, as my Brazil customers. This is it. So when I execute this, that's a creation process. I'm creating a new object. And this is the first time I'm running this. And this object does not exist on the server. So it will go ahead and create it. That has been created, the query executed successfully. What's the implication? A new view called Brazil customers has been added. I don't see it right away. I can refresh. That's the power of refresh. I see students just clicking on anything and refreshing. If you want to refresh the views folder, make sure you click on view. The system needs to know what you are refreshing. Don't be on HRO and then you're trying to refresh the views folder of Northwind. No, it doesn't work. If you click on this, you're refreshing HRO. If you click on inventory, you're refreshing inventory. If you click on views folder in Northwind, you're refreshing that particular one. If you click on this, you're refreshing Northwind, you see. So the refresh button on its own it needs to go with the highlighting process. You highlight what you want to refresh. I want to refresh this, I highlight, then I refresh. So if I expand on views, I now see the view folder we created. See? And once you create something, how can you exploit? Select star as exploration, just like we do for physical tables. I want to alter that. See, my current views table, basic customers, has just 2 columns. How do you alter it and make the changes? I've shown you this approach. What if you never had access to a database view that was created? You don't have access to the syntax. We just went here and changed create to alter. What if you don't have access to the syntax? And that's another way I can show you. And this is what you find in companies. For example, I can tell you to explore the invoice. Invoices is an example of a views in the Northern database. Invoice, this is it right here. I want you to check out the query that was used to build the invoices view. It's easy. Right click. This is very important. Every object on SQL Server has the script option. This is what we call scripting. Scripting is the process of generating the SQL code that was used to build an object. So whenever you right click on any object and you see the scripting option right here, script, since I right click on a view, I see script view as. If you want to see the create statement that was used to create that table, this is it. You go to this segment and you put it on a new query editor window. The system will put the code together for you. Very powerful. You can join a company and they tell you, hey, can you just go ahead and update, add more columns or modify the logic of the invoices view? This is what you do. You don't have access to, you don't know the code, but then everything is saved on the server. You can find that information. This is the code. This is what the system will present to you. This is what was used to create the invoices database. The invoices view. You see that one line of code at the very top. That's the same thing we've seen today. Besides the select statement, which you all know, you add this one line of code at the very top on the create. When you're creating for the very first time this line of code, that's the same thing we see right here. Let me repeat this process again. It's not just for views, any object. For example, let me take you to the customers table. Go to tables on Northwind customers. Right click on the customers table. I want the system to give me or show me the code that was used to create the customers table. Scripting, this is very important. Once you right click on any object and you see script, you can then follow through. I want to get the creation, the create statement, put this on a new query window, and this is what you get. The system builds, the database engine will put together the code that was used to build that object. This is very powerful. This is it. And this is the concept I've pushed forward. We're going to see how to create table. This is a create table. This is the name of a table. And then next you see every single column in that table. Every column has a name, it has a data type, and it has a constraint. We're going to visit this process. Right. I'm going to dismiss this for now. Right. So it's not just for views, it's available for tables. Let's go back to the invoice. Let's go, that's a view. So you have a request from your manager. Add some columns. They give you specific columns they want you to add in the invoices view. Don't go complaining, hey, what was the query that was used to create the invoices view? You can find out for yourself. This is it. right-clicking, scripting. Great. If we want to alter that view, this is what you do. If you want to create it, see the syntax for the creating. Alter and create is basically the same full code, but then on create, you see create. On alter, you see alter. The create will be replaced by alter. So this is what let me show you. If you went for the alter, then just a moment for this to load. So it's building the SQL script that was used to create the invoices view, the invoices view. If you went for the second one, alter, this will be replaced, and you see an alter right here. If you went for create, you get a create right there, and this portion will be the same. So this is a one line of code you add. You have a select statement. You put in so much effort to build a select statement. I don't want to lose it, or you don't want to save it outside management studio. You want to save it on the server so that your other colleagues can use it. That's a view. Just transform it into a view. See, you see the process involved right here. This table joined to this, and it is saved. And whenever you do select star from the invoices view, this is the query that is running behind the scene. Get that information. You see? And then if it tell you now to add some logic or modify some logic, switch this first to an alter, and then go there and make whatever changes you want to make. See that? This is very important. So whenever you are doing a select, let me go to a new query window. I want to explore the invoices view. When you're doing a select star from the invoices view, there's DBO dot. It's a view basic customers invoices right here. So both tables and views are stored in schemas. See that? That's why you can refer. You see DBO. This is a view, not a table. It's a virtual table. This is it. When you're doing a select star from this, see what you're getting right here. That is built from this query. So right click, scripting, very powerful. Put it on a new query window. The system will build the code that was used to generate that view. And if I highlight just the code part of it, not the first line that says create, I just want to see this. This is the select statement part of it. You see, if I execute just the select statement, I get the same thing I get on this side. So you see how simplified this is. Instead of building this every now and then, you're running all of these terrible things you see right here. Yeah, this is just clean stuff. All that information has been saved under this. And if I run this clean, I get that same outcome, but then the front end looks very clean. This is the back end to that code. This is a confusing thing that's going on behind that code. You see, a lot of things put together. But then all this has been documented and saved into this invoices. When I select star from invoices, I am getting this upfront clean and see. But this is what is going on behind the scene. This query is running behind the scene to show you this result. So you've built all of this. This is what the company has prepared. There are people that once you're hired, I think I execute part of that script. They even build a query like this, give it to you and say, okay, use this view. This is what they built at the back end, saved it in this view, right? And then give you this name. This is where you begin your analysis. See, you've skipped all of this build process. This is where you begin your analysis. Now use this virtual table right here to build us a report. This is where your analysis starts. You don't have access to all this shippers table, the products table, the employees table. You don't have. You just have this one final view called invoices. And that's where your analysis begins. Everything you need to build a report is right here. But this report you see right here, they've had to go through 4, 5, 6, sometimes 10 tables to package it and see. That's the power of views. Right. So if you want to edit the Brazil customers, right click, go to script the view, alter statement, put it on a new query window. It now shows up in an alter environment. And the power and the alter environment gives you the ability now to put a comma right here and type those missing. See, now you have a good start. See, it builds the code for you, and you can just add the logics you want to modify. What did we modify? We added 4 new columns. Right, let me go to the alter statement for Brazil. We added 4 new columns. These are them right here. I want you to understand that currently the Brazil customers has two columns. I have now projected the Brazil customers in an alter environment. It has shown me the code that was used, and I just want to add these 4 columns to the list. See, and if I execute this, I have altered the Brazil customers by adding 4 more columns to the list. And I can execute. So please, if you have this kind of questions to modify or change the logic of an existing view, you don't need to start panicking and asking where is the query. Everything's available for you. Just right click on it, you access the definition, and then you start modifying. Push it in the alter platform. That view has been altered. The query ran successfully. What does that mean? It means if I go back to this and execute, I will no longer see 4 columns, 2 columns. I will see the 4 I added, 6 in total. Now, that's it about views. So if you're building a report, let me just go back to what we did today. Today we ran some very interesting codes. Let me go to open the one that was taking forever to load. You can now go back to your lab 6 and save all those queries we built. Solve the question and then save the script as a view. Save the script as a view. So I'm going back to lab 6. Lab 6. These are the labs we solved today. We've done the first 5. You will do 6 and 7. I want to go back. This question right here, you can take this, save this as a view. Once you're done fixing that first code, save this as a view. That's invalid. I'm in the wrong database. I'm on Northwind, so I have to switch to this. Right. So save this as a view. Let me add it to this. So these are examples. I'm going to add. Let me just take it all the way to the bottom. That is a new concept I'm adding. All the way to the bottom. And just imagine this question was given to you. So this is the query right here. Let me connect to the appropriate database. This is AdventureWorks 2022. And this is the query right here. Save the query below as a view. What do we, well, let me just make up a name for this. Let's run this and see. Again, I keep forgetting to run the database connection. So what are we actually counting right here? The employees. Let's do. Yeah, let's just do count. This is a count by person type. So if you have this kind of question, save the query below as a view. Name this. See, that's it. All information you need is provided. Given this query, let's proceed to save it as a view. That's the query right there. To save this as a view, you just need to add one line of code to do this job. One line of code. And what's that line of code? Is what? Create. What are we creating? We're creating a view. What is the name of the view? Count by person type right here. I've forgotten something. What am I missing? And that's something you always miss when you start building views. You always miss that. Can somebody help me fix this? I've forgotten one keyword in the create view statement.
Is it us?
Yes, excellent. You always forget this. Yeah, after a while you get it. Now this right here, I've always been using Go, but I've never really explained. Now view must be the only statement in a batch. We use Go to put things into different batches. You see, when I stay right here, and this helps to explain the meaning of this Go. When I stay right here, this is a statement. This is also a statement. They are on the same batch. It is really not an error. If I run this, it's going to execute. But then you get this annoying line right here because you put this and this on the same batch. We use Go to split things into different batches. See that funny line goes away. So a Go is a batch terminator. Right. So I put this statement and I put Go right here. This statement is inside a batch of its own. Right. I put this statement on the next batch. You see, that's it. And one way to test and understand the importance of a batch is this. I do select, get date. Oh, let me show you this. Create, let me do this. I will come back to this concept again when we are showing you how to create databases. Create database. See, this is a valid statement, and then whenever you create a database, you connect to it. These are two. I put them together and execute at the same time. I get an error. Please, this is very correct. All this is correct. This is correct. My only problem is that I am creating something, which is what test one, and in the same batch, I'm using the right SQL language now. In the same batch, I'm trying to connect to it. If I execute these two, they run at the same time. You cannot create something and connect to it at the same time. By the time the system is running this, is building this does not exist. So by putting them together, you're putting them in the same batch. They will be executed at the same time. So you cannot execute something, create it, and then connect the same thing you just created at the same time. So the power of a batch is when you step in and put a go right here. This will be executed together, but they will be run or executed one after the other. So this goes in first as the first batch, followed by this. That's the meaning of a batch. So the system, although you are submitting this together, the system first of all builds this. The test one exists. Then now you can connect to the test one. You cannot build something and connect to the thing at the same time within the same batch. Now that goes through, you see. So a batch is just a way to usher in your code in a specific order. This goes in first. This process is a precursor of this. You cannot connect to something that you've not yet created, and you cannot create and connect in the same batch. So I'll come back to that concept when we are studying creating databases. So when you start seeing that concept right here, it tells you a view must be the only thing in a batch. When you start seeing those kind of errors, just put this right here. It is not an incorrect syntax. if I execute this, it creates the view, right? But then if you're submitting this code in together with multiple codes to be executed, you have to guide the process and say, hey, this should be run on a separate batch. That's just the meaning of Go. But without the Go, this is still a valid syntax. It will still go ahead and create the view. So we are transforming that select statement into this view. See it executed. And now we can test the view or explore the view, whatever you want to call it, by doing what? Explore. This is exploring the view. And what's the name of the view? Let me put the name exploring this view. Right, and how do you explore a view? Select star from, you just type in the name, execute. You see the power of this. This is one small stuff right here, but this is built from this long code you see right here. See? This is what you type, but then this is what somebody will use upfront. So you save time, you build this one, save it on the views folder, and your colleagues can just use this for the analysis. This is a good start right there. And I can then go ahead to do other things in this. That's the power of views. See, I skipped some examples. So this annoying line right here, you can just put a Go and it will make sure that the view appears on a separate batch of its own. I did skip some examples, but this is a very interesting stuff. If you look at this code right here, is putting together how many tables? Can somebody tell me the number of tables involved in this select statement? I'm just highlighting only the select statement, this, and I'm clicking execute. How many tables are involved in this select statement? We've always said that if you have
five.
Okay, 5. So let's count. You can always look at the joins 1, 2, 3, 4 plus 1, 5. There'll be 5 tables. If you see 4 joins, there are 5 tables. If you see 3 joins, there are 4 tables. So for n tables, you need n minus 1 joins. See, this thing took how many minutes? 37 seconds to run, and it generated this number of rows. That's the query we use today. Yes, that's that query we use in an example today. See that? Now, you've built this. Each time this question shows up, you don't need to be building this over and over. You can just save this in a view called customer purchase. So if I now execute together with the create, I'm now taking this SQL query right here with this output right here containing 121,000, that number of rows with 1, 2, 3, 4 columns. I want to save it in this. And once I put it as a view on the server, others will have access to it. See? Now, once I run this, the system creates a view out of this process. And how do you explore that view? This is the view right here, customer purchase. I just do a select star or call those column names and execute. Compare this one line of code, this table, right, this one stuff right here with all of this information stored. See, that's the source right here. But this is what you're getting. All of this has been stored in one virtual table called this. So basically 5 tables have been combined together into one virtual table called customer purchase. There's so much power to this. These are separately physical tables which will exist independently of each other. If you go to the tables folder, you see this separately. There will never be an instance where this will be put together. Only views can do that. So you pull them together and then you store them into this. So the customer purchase view contains 5 different tables. right? So when you're doing a select star from that table, from that view, you have to understand that a process is running behind the scene in those 5 different tables together to render this result you see right here. It looks simple right here, but then this is the full details of what is going on behind the scene. Right, so views are very powerful. Yeah, I'm not going to introduce subqueries today. We're going to do that tomorrow. I don't want to. Yeah, we'll push it to tomorrow. So tomorrow we have an increase in list of requirements. So tomorrow we're going to be looking at variable stored procedures, and then I'll start off by looking at subqueries. Again, subqueries, like we're going to see tomorrow, is a query inside a query. We're just trying to modify the things we already know. You see, the whole concept of views is just one line of code. It's still the same select statement we've been building. And I'm just telling you, hey, just add one line of code to this. This is all you add, and you save that stuff. So today we've really not learned anything new or special on views, right? The definition, the syntax, application examples. This is it. So it's heavily built on the knowledge of your select statement. We've used this query in the lab 6. This one of the questions that says use the following query as a base. This is the query right here. Right. Now we just add one line of code. It creates, and if you go to AdventureWorks 2022, you will see this data, this view you created. Let's explore that. That's a view, so you cannot go to the database, the table. So the first thing, let me just refresh this and have a fresh start. Go to AdventureWorks. The view was created in AdventureWorks 2022. This is it. Expand. We are not going to the physical tables. We're going to the views folder. And then these views are always listed alphabetically. So customer, that's a C. You see it right here, customer purchase. That is a view we created. If you never had access to this code, you can right click on that view. This is a very powerful thing I'm showing you right here. The ability to script out any object on SQL Server. The scripting is very powerful. Create new query window. The system builds the code that was used to generate the view. This is one very powerful thing you take out of this lecture. The ability to ask the system to build the script that was used in creating any object. Remember that code involved what 5 tables. So see, it's putting together the script behind the customer purchase view. And you can explore other views. You see, there's a lot of views on that AdventureWorks 2022. You can explore other views. I think my system is just slow today. Okay, any question before we go? I think let's wait for this to load. So you understand what we're going to be targeting tomorrow. I will address subqueries. It's simply you write one select statement, you write another select statement, you put one into another. So it's all about select statement, right? And that's what we're going to explore tomorrow. A very interesting segment, right? And now we talk about variables and stored procedures, and that will be the end for week 7. We're gradually getting towards the end. Week 8, we have one more, and then I think I will have to talk with Mr. Muke, which I will need one extra week to address the aspect of creating tables, databases, inserting records into tables. And then we're going to do an end-to-end project where you're going to create a database and then you solve all the questions involved. Right. That will be the last week of the training. This is still loading. Let me use opportunity to highlight so that you have to understand the next topics we have. I've also window for we have. I think this thing has executed. So yeah, this is the query right here. That same query. This is it. This is what I requested. This is what we had in the notes. This is it. This is the notes. See, this is the request I made for SQL Server to show me the code that was used to build the customer purchase database. And usually when individuals are building this, they just always put a comment towards the end that has the date stamp when the view was built. And the date of today, it's I just put this. So while you're executing the create statement on the view, you just at the end you just put like a date, a timestamp when it was actually built as a comment, because this is 2024. This is 2nd of January to February, not March, sorry, March 2nd. Date created, then created by, or you can put it right here. Date created, then created by the individual. Right, that's just for documentation. Right. So we have window functions. No, so we've done window functions. So tomorrow we're gonna talk about variables and subqueries. That will be the end of week 7. Then week 8, we're gonna look at common table expressions, derived tables, and I'm going to show you how you can build your own functions, user-defined functions. And then back to creating databases, creating tables, so that you are given a project, you can do an end-to-end. You see a lot of end-to-end projects on LinkedIn. Let me show you one example. Right, like the interview questions we've been exploring. You see an interview question, they give you the data. So this is an end-to-end project right here. This person just posted this. This was posted 9 hours ago. This is the kind of things I'm talking about, an end-to-end project. So this is a finance analysis project. This is provided by this individual. They start by, these are people who are studying just like you to find jobs. They see the projects that they are sharing on LinkedIn. This is the key part. If you're giving this database tables, can use go into SQL Server Management Studio, create these tables, and then start solving the questions that follow. This is an end-to-end project. You create the database. So we're going to do this. All right, I'm going to show you how to create the customers table, insert all this data, create the accounts table, insert all this data, create the transaction table, insert all this data, create the branches table, insert all this data. When you have this created, of course, you're going to choose a name for the database. You cannot just create tables with a database. Yeah, you have to define the database, create all these tables, then go to question 1. What are the names of all customers who live in New York? No table has been told in this, but what is the goal of this? Names of all customers. We have a customers table. You see, now if you go to the database, it is a customers table, the names of all customers who live in New York. There's a customers table. There's going to be a where clause, city equal to New York. And you can be showing the word, the first and the last name. It depends on the question. So something you build, you now follow that up with questions. Right? You build a database yourself, and then you solve questions on what you've built. Right? See, it becomes really interesting. Right? And you see a lot of this kind of stuff popping up on LinkedIn. These are individuals just like you who are, looking for opportunities in data analytics. This guy is a data analyst intern. Maybe they're attached to a company doing internship, and you see they are showing their skill set. These projects are available all over the place. You have to first of all start by building the database, and then you solve a series of questions based on the database you've built. This is very important. And when I see something like that, I just click a like. And then if I go to my liked articles on LinkedIn, I have the list right there. And this is what I'll be doing. I will be showing you these projects, and you're going to recreate your own. You build those projects. These are end-to-end projects. Create a database. See, this is what I just like. And other lists. This is what we're going to see in week 8. This is what we call a common table expression. This is a dashboard with the global superstore database. You can build this in Power BI. You're going to get to that. Just you see. So yes, we're going to have an end-to-end project. You're going to start by creating a database and then solve a series of questions that follow after the database has been created. This is another one right here. This is a project on customer insight. This person aspiring data analyst, and you see a lot of the Indians, these guys are hardworking. See, this is very, very important. Why we are fasting and praying in Africa, these guys are hardworking. They're also very religious, but they believe in hard work. I work with Indians. I study with them as well. This is very important. I really want to challenge you guys. Yeah, we have a feeling that in Africa we're sleeping. In IT, these guys were in IT a long time ago. We just came and joined them, and now we're trying to catch up. And it proves all these projects I'm showing you, they're Indians. All. See, this is it. Again, the database is gonna build. I'll challenge every one of us. We build this. This is a project that we're gonna do in the last week of the training. Right? See, you see, every one of them I'm showing you, these are Indian. Right? And there's no surprise why they dominate the IT field. Right? They're hardworking. Okay, we're gonna end here for today. So now you understand we have 2 more weeks to go. Next week and then the project week. And then we're gonna round up. So please keep studying, keep working, keep reading. Right? And if you have any challenges, reach out. I use a lot of LinkedIn. There's a lot of inspiration on LinkedIn. You have to see what others are doing and challenge yourself. Things are becoming very competitive, right? Okay, so we're going to see tomorrow. So you understand what we're going to be looking at. We're going to push subqueries to tomorrow. And then next, we're going to look at variables and start procedures. Okay, see you tomorrow. Bye, everyone.
Yeah, bye, Mr. Bliss. See you tomorrow.